Okay. YouTube claims that I'm live, so I suppose that should be true by now, right? Welcome all in. Zoran, Stevie. Can you hear some noise in my microphone while I'm not speaking? Okay. Let me just set up noise gate for that. You see me and hear me, okay. Testing. Well, Zoran said yes, so obviously he has his speakers turned up, and I can see in my meter that there's some noise coming. I'm just not sure from where. So set up a noise gate to basically cut off the sound completely while I'm not talking. That should be okay. If it's not okay, if it's when I start a new sentence after I have not been talking for more than a second, if you cannot hear my like a first letter of the next word, or if my beginning of the sentence is a little bit cut off, let me know and I'm gonna tune it a little. HP laptop fan noisy, headphones, and Dragonian, hello. Yeah, in the head. Tune it? What do you mean, Zoran, by tune it? Is it not okay now? It's already cutting off. Okay. Okay, I have moved it a little bit. How about now? Zoran is my testing man. If Zoran has no problems, then nobody will have problems. Stevie, you can. I just you just type your question and I will answer it after I tune the sound with Zoran. Better for me. Okay, I'm gonna move my sliders just a little bit more to be on the safe side. And if any of you can not understand anything, like with any kind of issue with my microphone, please do tell immediately because I want everything to be recorded properly, right? But I also don't want you to hear noise when it's not needed, right? Okay, so to answer Zoran's first question about moving the stream to 1 hour earlier than we started today, that is perfectly fine for me because the last time I was actually wanting to do that as well, but everyone in chat was like, oh, all is fine with me, all is fine with me, we can start again at the same time, and it just stayed the same as the last time. So we already have 3 votes to move it 1 hour earlier, and just a second, I need to answer my door. This was unexpected. Okay, so how was that? I know I did not mute my microphone, so you might have picked up what happened with my neighbors. Basically, my neighbor came to ask for some yogurt, and she brought some cakes, like freshly baked cakes, which I'm probably not going to eat right now, but they look delicious. Okay, so we are where? Okay, so it's almost like you didn't even notice that I was gone for a couple of minutes. Nice. Um, Dale Anderson, can we talk in pluses and minuses? Because if I start converting again, I'm going to make a problem. So whenever we started today, so meaning 8 minutes ago, just move it 1 hour earlier, okay? Whatever it is on your end of the time zone, just 1 hour earlier, and that's fine. Stevie, yes, I already told you that you can ask off-topic question. I told you to start typing while I'm discussing the sound with others. You're free to type, right? Zoran, you're correct. The only problem is that I am never sure about the difference between UTC and GMT because one of them is fixed and the other one moves with the daylight time saving, right? But during the winter time, which is now, I think both UTC and GMT are the same. Dale Anderson is still, no, Stevie is still typing his question. Okay, I was actually going to do something, let me see. I need to borrow this chat for a moment. Oh, you can't see my chat, okay. That's actually fine. Iceblade has voted for the current hour. Yeah, I mean, I'm pretty sure that we are moving it 1 hour ahead, but let's see closer to the end of the stream what happens. Give me just a second. I'm just tuning something in stream. Why is my chat always moving? Okay, so Stevie, I switched to Open Mandriva on your main PC. Okay, that's bold for the time of testing, right? But for some reason, when I copy something on, for example, Brave, I copy something. Okay, and try to paste. Oh, copy the clipboard and try to paste it to some other application. It just pastes the last thing I copied from that application. Well, Stevie, on Linux, I don't think this is a Mandriva specific issue because on Linux you have a couple of clipboards. and it depends somewhat on the program that you're using and the desktop environment. So one of the ways you can copy paste things is by just selecting with your mouse. And as soon as you select with the mouse, it will already be copied into one of the clipboards. And you can paste that data with clicking the middle mouse button. That's one way, and it doesn't work in all applications. Another way is the classic one that you are used to in Windows and Linux. So highlight and Control C and Control V. But that one also doesn't work in every possible scenario. Particularly in terminals, there is also a third way to copy paste, and that's like selecting with the mouse. And let me remind myself, it's Control Shift C and Control Shift V. And this is usually specific to terminals. Unless you're talking about Vim or Emacs, they have the fourth and fifth mode of copy pasting, but let's not go there. My chat is really in a weird position. Okay, I fixed it. Yeah, I don't know. We can give it a test. I still have Mandriva installed on my laptop. We can test it near the end of the stream, and we are already like 15 minutes into this. So let's start doing something. How's the text size on the PDF? If you need it bigger, I will just remove the chat and make it full screen. Brad and Jerry, hi. Zoran says yes, which would be an answer to increasing the size. Good size? Well, it's fine. Oh, everyone says good size. Who said yes, please? Zoran? And then you said good size. Yeah. Okay. I can actually move it slightly above. There we go. Good, Sise. Okay. Nice one. Yeah, okay. So booting the system. This one is a little bit... okay. The whole thing is a little bit delayed for me. So the moment when I read it and the moment when you hear it back, I'm not sure how long it takes. I have set it to the shortest possible delay that YouTube can handle. So we can chat at least somewhat live, right? And YouTube has 3 options. So I'm using the fastest, like shortest delay, and there is a middle delay and long delay. Long delay gives me an option to turn on subtitles because it gives YouTube enough time to process my voice and generate subtitles. The middle one, I don't know which features does it have. And the fastest one that I'm using now is obviously the benefit is as live as possible chat, right? Okay, so the today's lesson is slightly more how to put it, theoretical, and I don't suppose that we are going to need to test too many things in the terminal, right? But there is a couple of commands there that we are going to try just for fun. And they say the difficulty is like 3. Okay, key knowledge areas. One more thing, I have already typed this in the community announcements on my channel, but I'm a bit sick today, so if I start sounding really weird, it is what it is. I can't do much about it. Key knowledge areas. Switch between screens. Okay. Provide common commands to the bootloader and option to the kernel at boot time. Demonstrate knowledge of the boot sequence, from BIOS UEFI to boot completion, understanding of SysVinit and systemd. These are the most commonly used init daemons. Awareness of Upstart. This one is from Ubuntu, but it's no longer used. Check boot events in the log files. Partial list of the used files, terms and utilities, the message, journal, settle, BIOS, UEFI, bootloader, kernel, initramfs, init, SysVinit, systemd, etc. Okay, so that's just the introduction. Oh, this is the introduction. Okay, so that was the introduction to the introduction. In order to control the machine, the operating system's main component, the kernel, must be loaded by the program called Bootloader. Okay, which is itself is loaded by a pre-installed firmware such as BIOS. So in this case, bootloader is most of the time grub. Pendragonian, thanks a lot for joining. You're going to get a lot of video on demand videos available for you in a minute from now, or maybe sooner. Okay, so bootloader in most cases is grub on most modern systems. When I started back in the day with Linux, most popular bootloader was Lilo or Lilo in English, and then slowly grub took over. But there are many more. I think at least 5 more that are actually used these days. But if you just install any Linux distribution nowadays, chances are it will come preloaded with grub. Okay, so grub is being loaded by BIOS and the kernel is being loaded by grub, right? The bootloader can be customized to pass parameters to kernel, such as which partition contains the root file system or in which mode the operating system should execute. Once loaded, the kernel continues the boot process, identifying and configuring the hardware. Lastly, the kernel calls the utility responsible for starting and managing the system services. Okay, so this is, I would say, pretty much self-explanatory. Just some terms over here, maybe for Iceblade. I know that he appreciates when I explain some things that are not very obvious in this text. So which partition contains the root file system? I'm pretty sure that every one of you knows what partitions are. So that's where the kernel picks where to enter the root file system, from which it will branch out through the tree looking for its files, right, that it needs. And it will execute stuff from there. And once the kernel loads, it configures the hardware, right? So in most cases, okay, Dale Anderson. So in most cases, the kernel will, modern kernel, right? It's very different from today and before, because after the kernel started having modules, these are dynamically loaded drivers. This is what we have been talking about in the last stream. The kernel has the power to identify hardware that is installed, and then it automatically loads required modules / drivers, right? Previously, when no modules were available, then you would have to compile every driver into the kernel itself completely statically, right? So before, when you would move your hard drive to a different computer, most of it would simply not work because you would have to compile other set of drivers for another computer. And in today's installations, in most Linuxes today, you can just take out the hard drive, plug it into the other machine, and it will simply dynamically load all the new drivers for the new hardware that it detects on the when it's loading, right? So this is something that Windows is completely unable to do. And if you have ever tried to move a hard drive with Windows, right, from one computer to another, what happens is that Windows usually starts detecting new hardware, it starts installing new drivers, and this takes a while until it is fully ready to function. And sometimes it can break because it's not a big deal when you change a graphics card, and this is something that I suppose some of you have tried. For example, when you switch from AMD to NVIDIA, AMD's drivers will remain in the system, and NVIDIA's drivers will start automatically installing, at least the ones that come with Windows, right? And sometimes this causes issues, so you need to be careful about uninstalling the AMD driver before you reboot, that is before you shut down. And then you swap the cards, and then you boot up the computer without the GPU drivers, and then NVIDIA drivers start installing. This is this transfers to a lot other hardware, not just graphics cards. While in Linux, most hardware just works out of the box by the design of everything being in the kernel, right? All the drivers are in the kernel, except some of the proprietary ones, which usually means NVIDIA. With NVIDIA is a little bit different, but it's not too problematic because even when you swap between from AMD to NVIDIA on Linux, AMD uses open source drivers, and Linux also has open source drivers for NVIDIA. So that's good, because when you swap from AMD to NVIDIA, you will not be stopped from booting your system. System will boot, and the new driver for NVIDIA the open source one will load, and the AMD one will not load. So you will have a perfectly functioning system, except you won't have the top performance. And then you can just install NVIDIA driver, and that's it, right? It's relatively clean. Stevie says it would maybe be fun to, after completing this series, to do a Linux from scratch series and apply the knowledge we got from LPIC sessions. Well, that sounds fine. However, I was thinking about continuing with the next LPIC. Like, this is LPIC 1, there is LPIC 2. I think there is also LPIC 3. But the first two are bundled together for an exam, right? So I would like to. I am planning to do my exam, like, for real. So if any of you will want to do the same, that's, I think, also good. But at least I would like to finish the LPIC 1 and 2. And your idea sounds perfectly reasonable as well. On some Linux distributions, commands executed in this lesson may require root privileges. Okay, BIOS or UEFI. The BIOS, short for Basic Input-Output System, is a program stored in a non-volatile memory chip attached to the motherboard. Have you ever flashed a BIOS? And did anyone give you any warnings about being very careful about how you're doing it? The thing is, most modern motherboards have two BIOS flash EEPROMs, like two places where they can put BIOS in. So if flashing does not work out for some reason, the motherboard will try to wake up after the flashing, and if it cannot wake up, it will detect there is an issue, and it will automatically fall back to the previous BIOS. And I think most motherboards today have this. Previously, only the most expensive ones had this feature, and even before that, none motherboard had this feature. So you would have to be really careful about not flashing the wrong BIOS, or not losing the power while flashing, or not interrupting the flashing process, etc. Right? So one other example that I just like to give you an examples from my childhood, because that's my wife calling. Let me tell her that that's not a good idea. So, at one moment, I have had something, I think it was called Intel TX chipset with Pentium 200 megahertz MMX, if I recall correctly. And at some point, I flashed my BIOS in a way that it stopped working completely. It just, the motherboard simply did not boot anymore. And the old motherboards have had a really big BIOS flash memory. It was like this huge, and it was very easy to pull it out of the motherboard because it was just plugged into the socket, like a very old style chip, right? And how we fixed this, basically, I took my chip to my friend's house because we both had the same motherboard, and he booted his computer, which was completely functional. And when his computer booted up successfully, he pulled his BIOS out of the motherboard live while computer was running, and we plugged in my, let's say, faulty chip. It was not faulty, it just didn't have the right program up there. And then we flashed it, and then his motherboard successfully booted with my chip, and then I just took it home and it was all fine. But it was saved by a friend, right? If you don't have such a scenario, such a lucky scenario, right? It's a bad idea to not be careful. But as I said, modern BIOSes are pretty safe from these issues, right? Zoran says, I'm taking this opportunity to study for the LPIC 1-2 exam. Okay. Some 20 years ago, I decompiled BIOS and wrote my own DSCDT for running Hackintosh on MSI laptop. I have had Hackintosh installed on my Lenovo laptop, but I don't remember needing to do anything with the BIOS. I simply installed it like I would install any PC operating system because it was already prepared for PC hardware. Iceblade says, I have done that once, flashed it because the internet said so, but never understood why, and motherboard stayed dead. I mean, one of the most important reasons to flash, not the only reason, just one of the reasons to flash your BIOS fairly regularly is because you want to have new, what is it called, boot code. Is it called boot code? I think it is. CPUs, when they are produced, they have boot code on themselves, and they contain bugs and even security issues. And when the manufacturer, Intel, AMD, recognizes the problem with the processor, then they release the new boot code to the motherboard manufacturers, and the motherboard manufacturer gives you the BIOS update file. And when you update your BIOS, then you're no longer vulnerable to the problem that this CPU has. But even if you don't update the BIOS of the motherboard, you can buy a new CPU, the exact same one, just the new, how to put it, the newer production date, right? And it will not have this problem, right? Because they fix problems in their CPUs when they produce new ones. But since you're not going to buy a new CPU that is completely the same as the one that you already have, you will just flash your BIOS. And there is a third way to have the boot code patched, and that is relying on the operating system, that is kernel, to provide you with the protection from these vulnerabilities. And this is what Linus Torvalds does with his small team. This is not something that we can see in public. It is not a part of the kernel source code, right? This is a part, these are like blobs that are contained in the something called firmware CPU package of the operating system. Let me just pull it quickly here. Pacman firmware. Okay. Linux firmware files for Linux. I think this is the I'm pretty sure this is the package which contains all of the firmware required. So basically what you want to have is the latest firmware installed and provided for you basically by Linus Torvalds and his secret team that work tightly with Intel and AMD, and we don't have the source code for that. So that part is actually non-free. And if you install some of the GNU approved Linux distributions, such as the one that Richard Stallman uses, which is Trisquel. Trisquel is based on Ubuntu, but with everything non-free completely removed. And it uses something called a Linux Libre kernel. That one will actually not have the security protections that you need. So you will have to rely on your motherboard manufacturer to give you the updates, right? So that you can download those. Mark Carpenter, hello. Okay, Zoran, about the DVD player, yeah. Those are stupid times when DVDs were region locked. Linux did not get into the BIOS, they'll understand. I'm just explaining the procedure. If the CPU does not have the latest patches within itself, meaning it's not a newer manufacturing date, then the motherboard firmware will take over and load the required CPU microcode that is needed basically to patch the CPU. But this patching only happens once when you boot up your computer. When you turn off the power, the CPU is no longer patched. So if you move the CPU to another computer which has an older BIOS on the motherboard, it is not patched, right? The patch is only in the RAM, basically. And if the BIOS fails to load the more recent microcode than the CPU has, then Linux kernel will do that instead of the BIOS. So that's the third branch of protection. You know, like when defending yourself from the enemy, you have one firewall, the second one, and the third one. So if the first two fail, you will at least have the third one. So no, the kernel is not entering the BIOS. It is doing its thing after the BIOS wakes up, right? Because what the BIOS does, but the BIOS is the BIOS is the program that is literally flashed onto the memory that is usually soldered onto the motherboard, and the BIOS has the abilities to wake up this motherboard. Bootloader cannot wake up the motherboard. BIOS needs to do that, and as soon as the BIOS properly wakes up the motherboard and checks if the RAM is in place, the CPU is in place, and all that stuff, then the bootloader BIOS transfers the how do you call it in English? The what do you call that fire on the when there is a sports competition and when players are running with the fire in their hands and somebody else takes over. Basically, the BIOS will simply give the fucking stafeta. Some of you know that word for sure, to the bootloader, right? And when the bootloader takes over, the bootloader will the bootloader will load the kernel, and it will tell the kernel, here's your root partition, and do your stuff. Olympic sprint, yeah, I played. Pass the torch. Thanks, Del Anderson. I do my best with English, but you know, I can talk with people pretty well in the casual manner in English, right? But when it comes to somewhat less often used words, like words used in a professional manner in all kinds of various jobs, and even this with sports, right? It's not something that I use daily. I need to go around and explain my mind until the other people realize what I'm saying. relay race. Okay, Vladimir Mishev. Where we are. Okay. BIOS is executed every time the computer is powered on. So this is something that we already went through. This type of program is called firmware, right? And its storage location is separate from the other storage devices the system may have. Usually the SSD nowadays, right? Pass the torch is an English expression. In Olympics, the relay race is uses a baton, I think. Yeah, if I would have been given a little bit more time, I would probably remember the word torch, but baton, absolutely no. I don't even remember hearing this word. The BIOS assumes. Okay, now this is the fun part, and not always translatable to modern computers. The BIOS assumes, and note the word BIOS. This is important. So this BIOS, not this one. The BIOS assumes that the first 440 bytes in the first storage device, following the order defined in the BIOS configuration utility, are the first stage of the bootloader, also called bootstrap. So if you ever installed any more complex Linux operating system, and I mean complex in terms like Arch, and not Ubuntu, right? Ubuntu is just like click next, and you have no idea how this was installed, but suddenly it works, right? So Arch Linux will teach you a little bit about bootstrapping. So this is the first stage of the bootloader. The first 512 bytes of a storage device are named master boot record. I'm not sure how many of you remembers this, but anyone who is a little bit older will most certainly remember the word MBR. Iceblade, correct. You will learn soon what is the difference, because actually I'll just give you a spoiler. The master boot record is the old way of partitioning a hard drive or the SSD. The new one is called GPT. I'm pretty sure I did not say the wrong word. The modern AI confused me. Yeah, GPT, good partition table. Okay. When I said it out loud, I was thinking about, like, did I mix it up with ChatGPT? No. It's really called GPT. So the new partitioning table is called GPT. One of the most famous differences is that the old MBR type of partitioning has always only supported 4 partitions on your hard drive, while the GPT partitioning method, the new one, I don't know what is the limit, but it's big enough that you will never miss the amount of partitions that you want to have on your hard drive. So the advanced Linux users usually make more partitions on their computers if they want to manually take care of their systems. And usually not many of us create more than 2 partitions, because the first one is for the root file system and the second one is mostly for the home partition, because when you're reinstalling the operating system, you might want to just reinstall the system part and leave the home as is. Why delete everything if you can just leave it? The second reason to have 2 partitions is what I'm doing currently, is to not use the ext4 partitioning method, but rather the butter file system, btrfs or btrfs, because that partitioning method is not partitioning, file system, sorry. That file system is capable of snapshots. And what snapshot does, I will explain it in the most simple manner as I can. Snapshot basically tracks changes on your file system. So imagine that you have a system partition and you have a home partition. So in the system partition, for example, everything is working fine. and then you install some program. I'm going to invent an impossible scenario, but just imagine that this can happen. For example, your system works, and now you, for example, okay, this is actually not even impossible. You update the kernel, and the kernel updates itself in the system partition, right? And when the kernel updates, it makes some changes in the file system, right? The file system is changed, new files are installed, config files are changed. These are all changes. And what the Butter file system does with the snapshot system that it natively supports is it tracks only the changes that have been made since the last snapshot, okay? So what you would usually do when you are unsure if your change if you're unsure that your following change to the file system will result in working computer, then you just tell the system to make a snapshot. This takes less than a second, and then you have a baseline. And when you make a kernel update, then the system stores the difference from the snapshot moment to after the installing new kernel. This is usually not too much data, so it's not like it's making a backup copy of the entire partition. It's only making notes of what you have changed, okay, in a low-level way. And when you reboot, and if it so happens that you are unhappy with how the system works, for example, you broke it completely and it no longer boots, then you will go to the grub, and in grub you will select the previous snapshot. And what this will do, it will tell the kernel to load the partition as it was before the update. So basically what will happen, the system will boot up as you have never made any change to it regarding the kernel update. So this is really, really cool. Like, it works amazingly well. It takes less than a second to make a snapshot before you make changes, and it takes very little space on the hard drive after you start making the change. So it's a nice thing that you usually want to have on your system, especially if it's a rolling distribution, because these are traditionally less tested than the stable ones, right? Like Debian, right? Debian compared to Arch. It's not like I'm just saying that the, Arch will fall apart on you, but in theory, it has a higher chance of something like this happening compared to a stable version of Debian. So why did I drag this discussion for so long? One of the reasons is because I enjoy explaining various stuff that are not really related to this topic today, but eventually we will come to the file system, and then you will have aha moment, and that's it. That is nice, I think. The other reason is I wanted to touch on the MBR, because back in the day, people would love to. I'm going to catch up with chat soon. I just want my mind to spit out everything. Back in the day when we were using only MBR, we would have 4 partitions, and some advanced users would make more than 4 partitions, like root partition, var, home, user partition, maybe even editor as a 5th one. And how did they do that? Because if there is only 4 possible, and even swap is counted in this, so we are now at 6, right? Because swap is also a partition. So the way that Linux was handling this lack of technology, if I can put it this way, the Linux has always supported, not since always, but since back in the day, extended file system. Basically, Linux would create something, let's call it a virtual file system, virtual partition on hard drive, and the hard drive, the master boot record, would think that this is only one partition, but Linux would have many partitions inside this virtual partition. So from the angle of the hardware, right? The MBR. This part is not related to Linux. This is the technology back in the day. So from the MBR angle, you would usually have just one partition for all of the data, and let's say one for swap if it's like extra. So there's just two partition, but in the first one you would have many, so you could arrange them as much as you like. The most common reason to make a lot of different partitions was actually on servers, and it still is, especially where there are active users on servers, which was really a thing back in the day, right? When I started with Linux, I actually started with Unix before I even heard of Linux, and this is similar in terms of what I'm saying at this moment. I mean security. Public Unix servers would have like hundreds, if not even thousands of users, especially at universities, to which all of us would connect. And let's say home partition would be mounted as with the execute flag disabled for security, so that users could not put any executable files in their home folder. That was one of the most popular tunings to the server. And for example, in the user partition, you would need to have an execute flag, but you might attach some other flags for security there. You can do that on the partition level. So I don't want to go too deep into this, but let's say that GPT partition table has solved all of the problems that MBR had. And let me just catch up with some of the chat. You didn't actually write too much. Vladimir Mishev says 4 primary ones. Yeah, correct. GPT up to 128 partitions. Okay, good. Vladimir Mishev is basically typing exactly what I said. Good. I appreciate it. Mark Carpenter, the old computers that can't run Windows 11 will be MBR. Windows 11 have more than just one problem with the older computers, right? They're actually dropping support for CPU and stuff like that. Are there any downsides to Butterfile system over X4? Stevie asks. Are there any downsides? I will give you 2 downsides, which are not that big. These will be like minuses, but very minor ones. So the first minus to the Butterfile system compared to the X4 is simply the fact that Butterfile system is a lot younger, and Xfile system, the Linux one, whether it has number 2, 3, or 4 in the name, it doesn't matter. They're all very much alike. They have been out there since the very first day of Linux. Okay, so it's simply the sheer number of years that people have been running Ext as a default partition, and it has been tested in basically all possible scenarios. So it is really stable. Okay, if that makes sense. It is as stable as it can be. There is one caveat to that as well. So people say that Butterfile system is less stable, but it's not like it was actually proven in terms of like it's constantly crashing on people. That's not really the case. It's just that less years means less trust, right? So the developers of Btrfs are still improving it to this very day, and with every improvement it is getting even better. Okay, so if the development is faster than the discovery of problems, then I would consider it as stable as X4, if you know what I mean by that. The other thing, X4 has been known to fall apart to people, but here's the kicker. The what do they call them? The file system tools that come with each file system. So each file system has its own tools for managing the file system. So the ext4 file system has so goddamn good tools. So the tools are godlike. The tools can get the ext4 file system back from the grave, even in the most dire scenarios, like literally unplugging the power on a platter Rust hard drive many times and just booting and unplugging and booting and unplugging. Of course, you will make the system unusable if you do that too many times. But ext4 tools are so good that they can restore. I wouldn't bet my hand. I wouldn't put my hand in the fire that it will restore like every possible scenario, but it's actually well known that these tools are really, really good. So from that perspective, if something happens, you can rest be assured that you will be able to run like fsck, fsck command and just get the partition back up into a functional state. So that's the main difference. However, there is also xfs file system, which is not that popular outside of the Red Hat. I wanted to say community, but I meant ecosystem. But basically, that file system is really, really well done. Slower, but really well done. Like, if you don't want to rely on good tools to restore your file system from a slightly non-working condition, but you would rather have a partitioning system that is not partitioning, the file system that is actually better in terms of being more resilient to even getting itself to a non-functional state, that would be XFS. Of course, many other file systems are constantly being developed, and every author will claim that his is the best, and it is what it is, right? Marko Jovanovic, I apologize for not catching up that fast, but thank you very much for the 6. Thank you very much. I'm old school, Mark Carpenter. I run boot, root, ops, user, var, temp, swap, home in separate partitions. Yeah, that's... in my opinion, that is a little bit of overkill on the personal computer because you are slightly wasting space if you do that with ext. However, if you do that with the butter file system, then you don't need to waste space. And for those of you who don't know what I mean by this is with ext4, you have to tell the partition how big it is. So if you do what Mark Carpenter does, like put like 50 gigabytes on let's say root, 50 gigabytes on opt. I'm just putting out numbers that don't make sense, but it doesn't matter. Like you waste 50 gigabytes on one partition, on second, on the third one, and in the end, it leaves you very little space for your home partition where your actual stuff is, while you have wasted a lot of space on all these partitions. And I am not saying that Mark Carpenter did that. Maybe he did a very good configuration with his partitions, but having more partitions will always waste more space than having less partitions, right? However, with the butter file system, one other advantage, which is also something that I have on my computers, is you can make virtual butter file system partitions. So in most simpler terms, you make just one partition and you mount virtual butter file systems on top of the first one. This is a butter file system functionality, not Linux. Basically, it's Linux functionality, but it comes from butter file system. So you can have all of the separate partitions. If you have users on your computer and you want to be a good administrator and protect your server or computer from malicious users, you can tune it with separate flags for different partitions and whatnot. But each partition will take all of the space on your hard drive. all of the space as the underlying partition has taken. So if you say if you have 1 gigabyte hard drive, then opt partition will be 1 terabyte, user partition will be 1 terabyte, var partition will be 1 terabyte, temp partition will be 1 terabyte, home partition will be 1 terabyte. And this is just a feature of Butterfile system. It actually can do that. It simply fills them up, all of them at once. So if you put something in home partition, all of the partition kind of go up. I hope I have explained the functionality well enough. So through time, I am starting to be a sort of a Butterfile system fanboy, but it's simply because of the nice features, right? I need water. Chep Heavy. Ext file system is not FAT file system. You wrote FATX, but it's actually written XFAT, right? XFAT is Microsoft file system, and you would usually find it in Android phones, SD cards, or basically any SD cards in any device. Usually they all use either XFAT or FAT32, and these are fairly similar in what they do, right? So FAT is one file system, Ext is something completely else. FAT is from Microsoft, Ext is from Linux. They are totally not related in any way, but both are file systems. One of the biggest advantages of FAT is that every operating system can read FAT file system. So the most common thing you will find on USB sticks is having FAT file system on it, and usually it's either FAT32 or XFAT, because that one is the only file system that works in every Linux, in every Windows, in every Mac. Vladimir Mishev says, we said Butterfile system is fine for desktop, but not production ready yet. If I would choose a file system for a server, I would most probably still go with X4 or maybe XFS, because it's simply a matter of experience on my own skin. So I would agree with Vladimir. Dale Anderson says part of the problem was size limits on partitions when hard drives got too large for single or even 4 partitions. Dale Anderson is also correct on that one, but there were more reasons why GPT was invented, of course, so not just one reason. Stevie says, I meant to see that a lot of people are rocking Butterfile system. Okay. Dale Anderson, I think Ext is at partition level, not file system level. No, it's a file system. Dale Anderson, Ext is file system. Vladimir Mishev, today, as I see it, rule of the thumb for modern setup is Butterfile system for desktops, ZFS for storage. Yeah, I actually forgot. I actually forgot to mention ZFS. ZFS is basically the most advanced file system for storage and data integrity, but it is almost never used as a system file system or like home file system. It's not that common to do. There is very little chance that you will use ZFS on your laptop, for example. ZFS is at its most, how do I put it? the most benefits you will get out of ZFS is by not using only one hard drive. You'll need at least 2 hard drives to get some benefits out of ZFS. So using ZFS on only one hard drive brings very little sense. What ZFS does is it is extremely good in data integrity over multiple hard drives. So it's one of the most used ones on network attached storage. But for servers, I think X versus XFS is where the fight is usually. Iceblade says Butterfly system is like dynamic then in size. Dynamic, yes, but only if you set it up that way. By default, it's not like that. You need to know how to set it up in this way. Chap Cabby, you are welcome. Dale Anderson said I misread as extended partition, not X4. Yeah, you're correct. Vladimir Mishev, ZFS is default even on desktop FreeBSD. That is correct, but on Linux, ZFS is fairly a new thing. It hasn't been for a very long time, right? I don't know in which year ZFS arrived on Linux, but when it did, at that point, it was on BSD for many years already. I think on Unix as well, and it's a relatively old file system and really good at what it does. So whether the which BSD did you mention? Did you say FreeBSD? FreeBSD, yeah. As far as I remember, when you install FreeBSD on desktop, it will not choose ZFS. It will actually ask you which one you want. And I'm pretty sure I'm correct on that one, that it will ask you which partitioning, which file system you want. It will offer you ZFS versus, is it UFS, the other one? Don't forget snapshots, send, receive. Okay. Vladimir Mish, see you have already your FreeBSD laptop up and running. I just got mine last November and I'm loving it. Okay, let's... Chap Happy says that I'm correct. Thank you very much. BIOS and UEFI. The BIOS, okay, let's just repeat the sentence because I lost the edge. The BIOS, short for Basic Input-Output System, is a program stored on a non-volatile memory chip attached to the motherboard, executed every time the computer is powered on. This type of program is called firmware, and its storage location is separate from the other storage devices. The system may have hard drives. The BIOS assumes first 40 bytes in the first storage device, following the order defined in the BIOS configuration utility, and the first stage of the bootloader, also called bootstrap. The first 12 bytes of storage device are named the MBR master boot record of storage devices using the standard DOS partitioning scheme, and in addition to the first stage of the bootloader, contain the partition table. Okay, so the partition table is stored in the master boot record. Okay, so this is important. If you delete master boot record, then you no longer have your data at all. You have it, but it will be a pain to get it back. Okay, if the master boot record does not contain the correct data, the system will not be able to boot unless an alternative method is employed. Generally speaking, the pre-operating steps to boot a system equipped with BIOS are the post power on self-test, so the first moment when you see the RAM being counted. So post process is executed to identify simple hardware failures as soon as the machine is powered on. Then the BIOS activates the basic components to load the system, like video output, keyboard, and storage media. Then the BIOS loads the first stage of the bootloader from the MBR as defined in the BIOS configuration utility. The first stage of the bootloader calls the second stage of the bootloader, responsible for presenting boot options and loading the kernel. Okay, so this may sound as a lot of theory, but it's good enough if you just read this like 2 or 3 times, and it will be good enough to be able to get back to this when some of the later material gives you a link to this text. The UEFI, short for Unified Extensible Firmware Interface, differs from BIOS in some key points. As the BIOS, the UEFI is also a firmware, but it can identify partitions and read many file systems found in them. The UEFI does not rely on master boot record, taking into account only the settings stored in non-volatile memory (NVRAM) attached to the motherboard. These definitions indicate the locations of the UEFI compatible programs called EFI applications that will be executed automatically or called from a boot menu. Do you remember EFI applications from the last Sunday? So basically, when you have UEFI, usually you have also EFI partition, which is the boot one, and inside the EFI partition there is grub.efi application literally stored inside this partition. This partition is properly labeled so that UEFI can find it on your hard drive. It will go, the firmware will enter this partition. It will find several boot programs, bootloaders. If you only have one Linux installation, it will only be one grub, and it will give you an option to boot this grub, right? If you have multiple bootloaders, you can pick which one you want. For example, on my Lenovo laptop, I can press F12 to pick the different bootloader, and in theory, you can separate your Windows and your Linux installation like this. I'm not saying this is the best way. I'm just giving an example of what is possible. You can pull out one of your 2 hard drives. Pull it out completely. Then make a clean Windows install. Windows will make everything possible for itself to boot, right? When the installation is finished, pull out this hard drive, plug in another one, install Linux on it. Linux will set up grub for itself, and then put back both of them in. Turn on your computer, and what will happen is that the operating system which sits on the first drive, closer to number 0, that one will boot its operating system. But if you press the boot menu button on your keyboard to tell UEFI to give you an option to pick your bootloader, then the firmware UEFI, this one, right, will see that you have 2 EFI partitions on 2 different hard drives. It will look into each one of them. It will see that each one contains one bootloader, and it will offer to you both of them, and you can pick which one you want. So this is the most possible way to separate Windows from Linux, as I know, while both of them being plugged in at the same time. I did that a couple of times on my computer while I was dual booting, and the way I would do this is in Linux, I would simply tell my computer to completely ignore the Windows hard drive, like it doesn't exist. And in Windows, I would tell the device manager to disable the hard drive where my Linux is, so that there is no a possible way that Windows could even try to mount my Linux and do anything with it, and vice versa. So this is a good way to separate them if you want. Okay, these definitions, thank you for 100. Thank you for emojis. These definitions indicate the location of the UEFI compatible programs called FE applications that will be executed automatically or called from a boot menu. What I said right now. FE applications can be bootloaders, operating system selectors, tools for system diagnostics and repair, etc. So Ventoy has FE application on it that boots. I don't know who of you knows what Ventoy is. There are some relatively popular. I forgot the names, as I haven't been doing. When I was younger, I have been repairing a lot of computers. I had a USB stick with some tools pre-installed on it, with which I could load up all sorts of different tools, which would help me in repairing a computer. I just forgot what it was called, as I haven't worked with that for a long time. They must be in a conventional storage device partition and in a compatible file system. The standard compatible file systems are FAT12, FAT16, and FAT32 for block devices and ISO 9660 for optical media. This approach allows for the implementation of much more sophisticated tools than those possible with BIOS. Dale Anderson asks, isn't Ventoy security at some question? What do you mean, isn't it security? Isn't it a security issue, or isn't it a security tool? What do you mean? Okay, no reply from Anderson just yet. The partition containing the FE application is called the FE system partition, or just ESP. This partition must not be shared with other system file systems, like the root file system or user data file systems. Dale Anderson, as I recall, you could be right, as Ventoy might not be free software, to the best of my knowledge. To be honest, I only started using it recently, and it seemed like a really awesome idea for me, because I reinstall Linux and Windows a lot of times, right? And I only have like 3 or 4 USB sticks, and I keep overwriting them over and over and over again, and I keep putting on them the same operating system that I have had on them like 2 weeks ago. Because now I need to test something with Debian, now I need to test OpenMandriva, now I need to install Windows for some friend, and I keep shuffling them, and it was painful. So when I discovered Ventoy, it seemed like a really, really good thing to do. But then when the honeymoon was over, it wasn't actually the fact that it's not free software that got to me first. It was actually the problem that Ventoy actually cannot boot every ISO out there. So that's quite a deal breaker for me, because the way that you find out that it cannot boot some of the ISOs, for example OpenMandriva, is simply by trying to install an operating system for the first time, and then the installation fails, and then you have no idea why it failed. It just gives you errors, and then you don't know why. And then you flash the ISO onto the normal stick, and you do the exact same thing, and then it works. So what exactly Ventoy does is it changes some names of the partitions, IDs of the partitions, and it messes up with some of the installers, and this is really not cool. There was another thing, OpenBSD. I tried OpenBSD installer for the first time in my life by using Ventoy, and the installer absolutely worked. However, it behaved weird, and as I was installing it for the first time in my entire life, I wasn't sure what I'm doing wrong, or is this just how it is with OpenBSD. Basically, the installer is text mode, and it asks you a question. You give it an answer, you choose an option, and you press enter, and after you press enter, you would expect to be asked the next question, right? But between questions, the installer waits like 20 seconds at least, and it's a really long time. And whenever I answer the question to the installer, I need to wait like 20 plus seconds for the next question. And it felt really stupid, and I was like, there's no way that an operating system that exists for so long would behave like this stupid, especially as I'm booting it from an SSD, which is a Ventoy, right? And then I thought maybe it's some kind of weird Ventoy issue, and then I flashed it to my stick, and this is actually my slowest stick that I have, and it works perfectly. Immediately when I would press enter, I would get the next question. So what Ventoy does, I have no clue, but what I did take from all of this is I will most probably buy a lot more USB sticks and just have like 20 of them for all of the operating system that I need, because Ventoy is simply not, it's a good solution, but it's not the ultimate solution. So that's the problem. Vladimir Mishev, I don't get why is this part of the course. I mean, BIOS and BR-FAT, even I forgot when was the last time when I saw that in real life. Vladimir Mishev, if you want to be good at something, you have to know the past just as you have to know the present, right? That is my opinion, not just on Linux, but on most of the learning and developing yourself. Because if you don't know at least how it used to be, then you will not be able to, how do I put it? Let's give it this way. As a system administrator with EPIC certificate, there is a good chance that you actually will stumble upon an MBR partitioning table, simply because someone has left it running for a really, really long time, and now after 20 years, it has fallen apart, and your company is now, who you work for, is now asking you, hey, you system admin guy who has these certifications, can we send you to this customer? He will give us a lot of money to fix his old server. It's very important to him. And then you will say, no, sorry, boss, I only know how to work with new computers. I don't know how to work with the old ones. Please send someone else. Dale Anderson says the blobs in Ventoy make you wonder. I wish there was a free software. I also wish there was a free software alternative, because I bet it would work better. Iceblade says FAT32 sounds familiar. It's not common on USB stick. It is actually common, yeah. Most USB sticks are formatted as FAT32 or exFAT by default. And the developer allegedly has not answered questions about these blobs. Okay. Zoran, what Dale Anderson is saying is that when you boot Ventoy, it boots up a certain program, which then boots up your actual installer for the operating system, right? And this first part is not free or open source. Basically the same as Windows. So if you are willing to trust the proprietary code, then you are willing to trust it. If you are unwilling to trust it, then you're unwilling to trust it. It is what it is, right? Mark says, I still running computers that use MBR. Linux is so lightweight, it will run very well on older equipment. MBR can be installed on UEFI equipment. Yes, that is true. The EFI directory in the ESP partition contains the application pointed to by the entries saved in the NVRAM. Generally speaking, the pre-operating system bootstraps on a system with UEFI are power on self-test process is executed to identify simple hardware failures as soon as the machine powers on, so that's the same. The UEFI activates the basic components to load the system, like video output, keyboard, and storage media, so that is still the same. Then UEFI firmware reads the definitions stored in NVRAM to execute the predefined EFI applications stored in the ESP partitions file system. Usually the predefined EFI application is a bootloader. In our cases, usually it's grub. If the predefined EFI application is a bootloader, it will load the kernel to start the operating system. Well, I'm all fine with sarcasm, Vladimir. It's just that I don't even mind what you say at all. I'm just telling you that if you deny yourself the knowledge, then your value is lesser. You might be able to wiggle your way around this this fact about yourself in your life or in your business life, but at some point it might catch you. And in my business, it's usually a big W to, when there is a problem and the boss says that this needs to be solved as quickly as possible because it's some kind of an emergency with our customers. And it's a huge W when I'm the one who raises the hand and says, I can do this. And then they send me. And you know what happens when the paycheck comes? It doesn't have to be MBR. I'm just telling you that more knowledge equals better. The UEFI standard also supports a feature called Secure Boot, which only allows the... Vladimir says, I get you, but where one can practice any of that in practice? We're talking about course, right? Well, the first stage is to at least read what it says with understanding. This is already a very, very, very good knowledge. Just to read it with understanding, because there might be a scenario in your life when you're going to need this and you're going to remember vaguely what you read in this course, and then you will have like a faster time in Googling it for the result. Because when you start searching for the answer to the problem at hand, some of the answers that your search engine gives you, your long-term mind memory will fill up the blanks between the search results, and you will have an easier time in clicking the correct search result. So just by reading with understanding, this is a huge win just by doing that. If you can if you can get yourself another computer, It doesn't have to be an expensive one. It depends on how much you're willing to invest in the knowledge, right? You can always sorry, I have some distractions. You can always practice on your cheaply bought computer if you care that much about getting more of this old knowledge, right? Second. Malo ću se pauzati. Ask me some more questions, please. I need a small moment to take a break, as I am in a really bad shape today. Quite a bit sick, but I'm when I'm not in the best shape and when I talk a lot, it drains a lot of energy. Dale Anderson, I can tell you immediately that Ubuntu absolutely can do that. Which other Linux can do it out of the box, I'm not sure. But I'm willing to bet that there are more. Maybe even Fedora. I'm talking about secure boot, yeah. Maybe even Fedora and some others. Usually could be SUSE, but I guess you're going to have to look it up because the thing is, you can make every Linux distribution boot up with secure with secure boot enabled, but on some of them you're going to have to do it manually, which will take a little bit of effort. But on Ubuntu, I'm 100% sure that it does it out of the box. And not only that it does it out of the box, but also Ubuntu has the functionality that it can encrypt your home partition. Any Linux can do that, but every Linux, when you encrypt the home partition, will ask you for decryption password to decrypt the home partition when you boot your computer. Okay. What Ubuntu can do as an extra step is that Ubuntu is capable of storing the decryption key into the UEFI and then using this decryption key in your UEFI to boot your computer and have it decrypted immediately. So one of the scenarios where this could be useful is if you're some kind of a business person with business secrets and somehow somebody gets to your laptop which is like locked, and then they pull out your hard drive and plug it into another computer. On that computer it will not work because it will ask them for the decryption password, right? But in your computer it will just work, and you can do some extra steps in your computer. You can protect your UEFI with I don't know, fingerprint or something like that. Take a soda break. That's actually HTX80 nerd. That's actually a good idea. I'm not sure if I have something like that. I have some trash with sugar, I think. Give me half a minute. energy drains. Chap Happy, what is interesting? Will this do? Is this fine? HTX 80 nerd. Chap Heavy, it is a little bit more complex than that. And frankly, I don't know the complete story. But it's not like you wrote. It's not like you have written. It is the secure boot will be careful about stuff in the boot loader not being changed or something like that. Squirrel, nice. Need to fix my nose. Yeah, the camera died. Chap Happy, not your whole system. As far as I know, only the bootloader. Guys, we'll see about BSDs soon. The UEFI standard also supports a feature called Secure Boot, which only allows the execution of signed EFI applications, that is, EFI applications authorized by the hardware manufacturer. This feature increases the protection against malicious software, but it can make it difficult to install operating system not covered by the manufacturer's warranty. So basically what Chap Happy has asked, here is the answer to your question. So secure boot, literally as it says here, is the feature which allows only the execution of signed EFI applications. So what signed means, how this works. Let's take Ubuntu as a prime example of. I'm willing to bet they were the first to implement this even. So don't mind me using them as an example, because where the credit is due, right? When the operating system is initially installed, the bootloader grub is being placed into the EFI partition, and the operating system installer needs to update the UEFI firmware. It needs to tell UEFI firmware that we now have a bootloader that is called like this, right? And if the secure boot is enabled, then it also needs to upload the keys into the UEFI. And if your UEFI is like locked, for example, if you bought a Windows laptop, and some of the Windows laptops have a very difficult way to remove how do I say it? To remove the EFI secure boot feature, basically. It's a little bit of a pain in the ass, especially if you're installing FreeBSD. But I think most of the laptops nowadays actually have lessened this restriction. Only when Windows started implementing this, the laptop and motherboard manufacturers have been on board with being friends with Microsoft, and they did it the way they asked. And of course, the users have complained about not being able to install anything other than Windows. And you know how these things end, because if you are a hardware manufacturer and nobody wants to buy your hardware because it's not good for them, then you have a bad business, right? You can be friends with Microsoft and sell nothing. So where will that get you, right? Iceblade is correct on the last sentence. Okay, so the bootloader. The most popular bootloader for Linux on the x86 architecture is Grub, Grand Unified Bootloader. As soon as it is called by BIOS or the UEFI, Grub displays a list of operating systems available to boot, and this is what you configure in the Grub config file. It is what it is. It helps me a little bit. 90 calories? Where does it say? I cannot turn it on the side for obvious reasons. Uh, 46 calories in 100 milliliters, and this is 250. So 46 calories. 46 calories multiplied with 2.5. I would not say that this is low in sugar, actually. Uh, 28 grams of sugar in this bottle. So that's like 5 coffee sugars. Actually, quite a bad idea to drink this. Maybe you have read a description of another model of Hell energy drink. Sometimes the list does not appear automatically, but it can be invoked by pressing Shift while grub is being called by BIOS. In UEFI systems, the escape key should be used instead. Okay, Vladimir Mishev. From the grub menu, it is possible to choose which one of the installed kernels should be loaded and to pass new parameters to it. Most kernel parameters follow the pattern option equals value. Some of the most useful kernel parameters are ATSP, or is this read? How is this pronounced in English? I just read it ATSP. Enables, disables ATSP support. Init sets an alternative system initiator. For example, init equals bin bash will set the bash shell as the initiator. This means that a shell session will start just after the kernel boot process. Can you all imagine what this does? Like on a literal level. This is actually a useful command because in grub, Chep Heavy, thank you very much for the thank you very much for reminding people about the likes. Yes, you are correct. Iceblade. So what Grub offers you, it always offers you an option to not boot your default kernel, but instead boot another one, or to enter the grub command line, in which you can type the whole boot command that needs to be passed to the kernel. So you can type it manually, like please load. You're talking to grub, right? Like please load my kernel, but replace init with bin bash. So what this will does is it will load the kernel. All the drivers will stand up, and the system will not transfer further anything further to the init system, which is in most cases systemd. So the systemd will not execute, but instead you'll just get a bash shell. So why would you do this if the system is not working in this condition? Because you might be able to fix your system in this way after you have broken it. So this is another thing that is like useful to at least partially remember. Chep Heavy, if I remember correctly, Init will let you choose where to boot. This could also be inside a jail. You might be correct on that one, but don't hold me for a word on that one. Systemd unit sets the systemd target to be activated. For example, systemd unit equals graphical target. Systemd also accepts the numerical run levels as defined for SysVinit. To activate the run level 1, for example, it is only necessary to include the number 1 or the letter S, short for single, as a kernel parameter. Do you all remember, at least the older guys, do you remember the run level 1 on SysVinit systems of before, right? Even some modern Linux systems still rely on SysVinit, I think Gentoo and Dev1 and similar ones. So the reason, how would I put it? SysVinit has different run levels. Run level 1 is a single user mode. This is when your system is not booting up properly and you want to fix it, you tell the bootloader to boot the system in the run level 1, which will only give you root access and a shell and a chance to something similar to this, right? But it will start the init system and it will stop very soon and give you a shell access. Usually I think it tells you like press Ctrl D to enter the login screen to log in and to start working on your system. Run level 5 is a standard fully multi-user run level with the graphical interface, and the rest of them in between, I kind of forgot which one is which. I think 3 was like standard multi-user but without graphical user interface. I don't recall seeing anything about grub during install. Is that part of the installation process? No Linux present, only a Vim and the ISO. Dale Anderson, grub is always being installed on every Linux installation as the last step of the installation. So if you have done a graphical Linux installer, one of the easy ones, usually what it looks like, it has a graphical installer. It asks you your username, your partitions, and stuff like that, and then you wait for the system to install. That takes a couple of minutes, and at the very end, it might ask you where do you wish your bootloader to be installed, right? And you will pick your hard drive. But if there are no options to pick from, there may be a chance that there will be no questions. So if you have done it in a virtual machine, there may be no other options than just one. So it might be that you have not been given this question of where to install the bootloader. But if you have two hard drives, like put in your virtual machine, put two hard drives and install Linux again, and I bet it will ask you where do you want your bootloader to be installed, on this hard drive or on that one. Mark Carpenter, run levels back in the Lilo days. Yes, correctly. Exactly that. Oh, Dale Anderson, ROM installer shows a text menu, selected first option, then screen goes black and never comes back. This is in virtual machine, right? I have a solution for you. Let me go to the Open Mandriva. This is Open Mandriva matrix space, and I am 100% sure that some of the people in chat has asked the exact same question. So let's search for the word black, or maybe black screen. Okay, Neko is doing the heavy lifting and searching through the black holes. The word that I'm looking for might not be black. Where are we? Still at 13th of January. 13th, I guess that's fine. Let's do it like this. Can you please remind me how to fix There we go. Let's see how fast they answer to my question in chat. VirtualBox. No, we'll see. We'll see. Pendragonian, thank you for 220 of the TRYs, which is something I'm ashamed to say. I'm going to look it up, which money that is, which currency. Turkish lira. Okay. Amazing. Thank you very much for the €6 converted fast, because I just don't remember seeing the TRY letters before. Dale Anderson, sorry, did not mean to distract you, but I mentioned because one would hope that Linux distros would be able to install in a relatively uniform platform such as virtual machine. Listen, I actually agree with you. And I don't have any reasons to defend this uh, this particular scenario, and I actually think that in a VM there should be even less problems than on real hardware. This is the reason why I do all my testings on an actual laptop, because most Linux distributions work flawlessly on virtual hardware, and if something is not quite right, then it could manifest on the actual hardware, right? So this is why I test on actual hardware. And why OpenMandriva behaves like this, I guess we are going to find out soon when they answer to me in their chat. But this, the OpenMandriva community, right? This no company is standing behind these guys. So this is not like Ubuntu Canonical or OpenSUSE or Red Hat. This is a small team. And once again, I'm not defending. I'm going to get to the point of this. This is a community of people who is working on this, and they are fairly small. Hoću dobiti pasa? Ajde dođi lajka. So they are fairly small. And what I think how this should work out in the future, I think that we should join them as developers, as maintainers, as people who are willing to help, because that's how all of the community projects grow, including Debian. So Debian has been one of the two oldest distributions. I'm not sure if the Slackware is older or if Debian is older, but these two are the oldest ones that still exist. So, you know, how did Debian happen? Debian is a huge organization today, but how did they happen, right? There was Ian Murdoch, the guy behind Debian. He just decided to make a distribution because it was needed back in the day, and he made it, and people have joined him, and then he was able to start working faster because he had more help, and then more people joined, and then more people joined, and more. And what do we have now? We have a huge organization behind Debian, and it works awesome. Like hundreds of other distributions are built on top of Debian, right? Including Ubuntu, which is actually a company-backed distribution. So a company-backed distribution is based on a community created one. So what I'm saying is that the OpenMandriva, being a small team, I think they really deserved to get this sudden popularity spike, because inevitably this will allow them to discover more talent who is basically shunned or banned from other projects, if you know what I mean. And I'm not going to go into the politics right now. So what I was saying is that I think people who are willing to invest their time, I think they should join a project such as OpenMandriva, because they are in a big need of more hands, right? Debian doesn't need more hands. Arch does not need more hands. I mean, every project always needs more hands, but not as much as the small ones. Like they would really benefit from more maintainers. And the way you can become a maintainer is simply by telling them that you have the will and the time to learn and adapt to their process. And simply, let's put it this way: you are now a new OpenMandriva user, and you are missing one package in their repository, just one, and you want this package in there. So what you can do is simply ask them kindly, please add this package in there, and they will find who is going to maintain it. Or you can say, I need this package, I am willing to maintain it, like I am the one who is going to pay attention that this package gets automatically built every time that when it's updated, and I'm going to test every version in the OpenMandriva cooker version before I approve it to be released in the OpenMandriva ROM, and I'm going to be the one who people will be able to ping if something goes wrong, and I'm going to try to communicate with the upstream authors for this to be fixed, right? So this is how maintainers function, right? They don't do any actual programming, but rather they are maintaining a package, right? And small projects such as this one really need people who are willing to invest, and the best way to invest is to simply take care of the package which you need, and that's how you will create a bond with this package, right? Because you are going to be the one who is using it. Zoran, the oldest Linux distribution is Slackware, which was the first list released by Patrick Volkerding, okay, on 93. The second is Debian. So just 1 month later. Okay. Thank you for the data. Vladimir says Beehive, the BSD hypervisor, pronounced Beehive, is a hypervisor virtual machine manager available on FreeBSD and Illumos. Companies have an advantage for corporate customers who need support. Projects work better for individual users. I mean, you're not wrong. You're not wrong. I just felt the need to present you a really plausible scenario for anyone interested in joining the community in a productive way. Okay, so the mem parameter passed to the kernel sets the amount of available RAM memory for the system. This parameter is useful for virtual machines as to limit how much RAM will be available to each guest. Using mem equals half a gig will limit the RAM to half a gig to a particular guest system. So you don't really have to do this on virtual machines, because on virtual machines you will simply set it in the virtual machine manager usually. However, there is another example where I actually used this parameter. I was thinking about getting a laptop, a ThinkPad with soldered 8 gigabytes of memory, so not upgradable. And I was thinking whether I will be able to live with 8 gigs. And I actually used this parameter on my 32 gig laptop to shrink it to 8 and simply work on it for a while to see how it breathes. So no memory modules removal was needed. Simply a parameter that you pass to the kernel, and you now have 4 times less memory. Max CPUs limit the number of processors or processor cores visible to the system in symmetric multiprocessor machines. It is also useful for virtual machines. A value of 0 turns off the support for multiprocessor machines and has the same effect as kernel parameter no symmetric multiprocessing, no SMP. The parameter max CPUs equals 2 will limit the number of processors available to the operating system to 2 of them. Quiet will hide most boot messages. VGA selects the video mode. The parameter VGA equals ask will show a list of available video modes to choose from. This can be useful if you're changing monitors or something, and if you cannot work with some older monitor or something, or there is something going on here. They'll understand. Okay, I read your question. Root sets the root partition distinct from the one pre-configured in the bootloader. For example, root equals dev sda3. Root flags mount the options for the root file system. read-only marks the initial mount of the root file system as read-only. Read-write allows writing in the root file system during initial mount. Changing the kernel parameters is not usually required, but it can be useful to detect and solve operating system related problems, what I was saying for the past hour, right? Kernel parameters must be added to the file at its default grub in the line grub command line Linux to make them persistent across reboots. A new configuration file for the bootloader must be generated every time at its default grub changes, which is accomplished by the command grub make config with this file referenced, right? This is where you're going to set your options. And when you call this, then the configuration will be generated. Once the operating system is running, the kernel parameters used for loading the current session are available for reading in the file prots command line. Configuring grub will be discussed further in a later session. So let me load this prots command line. Okay, so here you can see my Arch Linux system, how it has booted. So boot image equals /et/boot /vmlinux dash linux. Root is this partition. Mounted read write with root flags sub volume equals @. Log level is 3. And do it quietly so don't show too many messages. So if you are wondering what the hell is going on here, so this is the kernel, right? This is literally the kernel file that is being loaded. And where does it reside? It resides at the path that starts with /et/. So what the hell is this? So this is Butterfile system. And this is what I was telling you about earlier, because the way I have configured my Butterfly system partitions is that the root file system is simply marked with @. So that's kind of the root one. And from there on, there goes the rest of the folders, right? It's how it's configured with the Butterfly system. This is not specific to any other file system. Root partition is this one. So the partition with the precise this UUID. And why is this presented with UUID and not with /dev/sda1 or /dev nvme something is because when we previously used to mount our partitions with grub with the root equals dev/sda1, and if you would swap the hard drives in your computer, then your boot hard drive would no longer be SDA1. Now it would be SDA2, and it could not boot. Also, if you would take it to a different computer and accidentally not plug it into the first port, first SATA port, then once again it would not be SDA, it would be SDB. So what this does is basically it tells the kernel to use the partition with precise this ID, and it will find it among all of the other partition. It doesn't matter which device it is. Dell Anderson, I'm getting some answers from these guys. Do you have NVIDIA card? So Zero Ability says this is a moderator. Yeah, moderator. He says it's probably NVIDIA switched to a VT and sudo DNF in NVIDIA, but you can't really boot, right? Yeah, actually you can. You can boot, but you have a blank screen. So what you can do is Control Alt, like F1, 2, 3, or some of the virtual terminals, right? Not the graphical interface, but one of the virtual terminals. Log into there and do what he says, sudo DNF install NVIDIA if that's what you have, or simply use X11 instead of the Wayland ISO. But also, if you have Wayland ISO already installed, you don't really have to reinstall with X11 distribution, right? You can simply add X11 SDM option by using a DNF command, which I don't know out of my mind, but I did say which one it is in my OpenMandriva review video. So I said there how you can switch between X11 and Wayland. You said VirtualBox, right? Yeah, so he says disable 3D acceleration if you really need Wayland. But he recommends rather to go with X11 instead. So I'm not exactly sure how much is this a problem with OpenMandriva, because Wayland is not implemented by OpenMandriva. It's actually implemented by KDE. So if you need these comments, I can maybe ask me to pull it back into the stream so you can make a screenshot or something. But yeah, just use the use no 3D acceleration in the VirtualBox for now, or reinstall with X11 version of the system. Configuring grub will be discussed further in a later lesson. System initialization. Apart from the kernel, the operating system depends on other components that provide the expected features. Okay, screenshot time. I hope you got it. Many of these components are loaded during the system initialization process, varying from simple shell scripts to more complex service programs. Scripts are often used to perform short-lived tasks that will run and terminate during the system initialization process. Services, also known as daemons, may be active all the time, as they can be responsible for intrinsic aspects of the operating system. The diversity of ways that startup scripts and daemons with the most different characteristics can be built into a Linux distribution is huge, a fact that historically hindered the development of a single solution that meets the expectations of maintainers and users of all Linux distributions. However, any tool that the distribution maintainers have chosen to perform this function will at least be able to start, stop, and restart system services. These actions are often performed by the system itself after a software update, for example, but the system administrator will will almost always need to manually restart the service after making modifications to its configuration file. Welcome back, Stevie. It is also convenient for a system administrator to be able to activate a particular set of daemons depending on the circumstances. It should be possible, for example, to run just a minimum set of services in order to perform system maintenance tasks. Strictly speaking, the operating system is just the kernel and its components which control the hardware and manage all processes. It's common, however, to use the term operating system more loosely to designate an entire group of distinct programs that make up the software environment where the user can perform the basic computational tasks. This is not mentioned here, but I have a feeling that this is trying to touch on GNU plus Linux part, because strictly speaking, the operating system is just the kernel and its components which control the hardware and manage all processes. So the way this sentence is structured, the operating system would be Linux plus systemd or Linux plus SysVinit. But what it was always preached to everyone basically is that, you know, when Richard Stallman was unhappy with the fact that all Unix systems were proprietary and cost money, then he made his own, and I am using quotations because he did not manage to finish the kernel. He managed to create everything else but the kernel. So that's why they call it GNU plus Linux, because it's like, I don't know if 200 is the correct number, but it's a lot of tools that GNU community led by Stallman have developed back in the day, and these tools are still being used today along with the Linux kernel, right? So we're not talking about graphical interface, we are talking about command line tools, because back in the day, command line tools were the interface of pretty much every Unix system. The initialization of the operating system starts when the bootloader loads the kernel into RAM. Then the kernel will take charge of the CPU and will start to detect and set up the fundamental aspects of the operating system, like basic hardware configuration and memory addressing. It might be, I'm not sure if this will be mentioned in this lecture, but this might be an interesting to the older guys of you. When we used to have 32-bit processors, like 20 years ago, or something like that, it was normal that the amount of RAM that we can allocate was somewhat more than 3 gigabytes. So allocating 4 gigabytes of RAM was actually not possible. But the Linux kernel was able to load a special mode, which I totally forgot what the name was, but Linux was able to enter a special mode in which it would be able to allocate all of the RAM that you have, so more than 4 gigs, even with a 32-bit processor. But it wouldn't be able to do that immediately, but rather the BIOS would load, like, I don't know, you have 8 gigs and BIOS would load only 3 point something. It would, I don't remember what it looked like, but the moment when the kernel started loading, then the RAM was allocated fully to the best of my knowledge. Memory training after post, yeah. But I don't remember what exactly happened when you would put 8 gigs into a machine that cannot do this. Maybe it would count up to 4 or something like that and then stop. But Linux kernel was the software that was able to get over this obstacle and load the rest of the RAM. It was a different it was differently allocated RAM in Linux, so that's important. It wasn't the same RAM. The first part of the RAM that 32-bit CPU could address was like some kind of a basic RAM, and now I'm talking a little bit after my ass, but I'm doing my best to remember. And the rest of the high memory was addressed slightly differently. So if I recall correctly, not everything was possible to be loaded into the high memory, right? Some things needed to start in the lower part of the RAM. Zoran says, like in the past with MS-DOS, like extended and expanded memory, when you had 1 megabyte of RAM and MS-DOS could load stuff, could not load stuff after the 640 kilobytes. You misspelled it. But yes, that's pretty similar scenario. The kernel will then open the initramfs. Mark says, didn't it run similar to a swap file? I don't know. I don't actually understand the question to the fullest. But even if you explain it better, I don't think I know the answer. So let's go with the following sentence. The kernel will then open the initramfs, initial RAM file system. The initramfs is an archive containing a file system used as a temporary root file system during the boot process. The main purpose of initramfs file is to provide the required modules so the kernel can access the real root file system of the operating system. As soon as the root file system is available, finally, the kernel will mount all file systems configured in etc tab, and most of you should be familiar with what etc tab is, but just in case if you're not. So etc tab, this is like line wrapping, right? etc tab is a file in which you specify all of the file systems which you want to mount when the system boots up. Okay, so for example, I have this partition and I mount that one as my root partition as a butter file system with these flags. Okay, also these flags because this is the same line. And then we have the second partition, which is actually the same partition. And this is what I was telling you about the features of butter file system. So we have the same partition, which we mount again as home, once again as butter file system with these flags. But the difference is that we are using a different sub-volume, okay? Here we are using /at, and here we are using /at home. This is something that I have configured during the operating system install because I wanted to use snapshots. And also we have some other partitions. So N1, P1, this is my EFI partition. This is where my bootloader is. NVMe1. So this is another SSD, but actually I took this one out of my computer recently because I have installed it into my future router to be because I'm making a router with OpenBSD and I needed this SSD, so I took it out. I guess I should. Actually, I already I already commented. Okay, I did good. And there is SDA. This is a SATA. This is a SATA drive, which I mounted in a normal way. Nothing fancy. Swap and my backup hard drive. Nothing fancy. These are all the file system stuff that gets mounted. If you type df, you will see something interesting regarding the my butter file system. I don't think that there is anything private on this screen, so all is good. So my root file system is one partition, and my home partition is a different file system. But both are filled up 85%. Both are filled up exactly the same. Okay, so this is what I was telling you. All of my butter file system partitions are filling up in parallel, and this is how I get multiple partitions so that I am able to do all kinds of trickery with the advantage of having more partitions, but without having the disadvantage of wasting space on a partition, which I have badly calculated to the how big it should be up front. So I just use the entire drive for all my partitions, and all of my partitions have 1 terabyte. So this is really good and practical. Chep Happy says no, because the CPU must have some sort of a table mapping to be able to identify the address after 4 gigs. Yeah, but I am 100% sure that what Linux would do is it would make the rest of the RAM available, but it would not be the exact same as the initial RAM. Let's ask AI quickly and see if it can answer our question. Is this a good question? Okay, so this is the name that I was trying to remember. To utilize 8 gigs of RAM on a 32-bit CPU with Linux, you need to use a 32-bit version of Linux that supports physical address extension. Physical address extension allows a 32-bit operating system to address more than 4 gigs of physical memory. Here are the steps to achieve this. Install installs automatically when it detects more than 3 gigs during installation. Alternatively, you can manually install the PyKernel. Okay, manual install the kernel, verify PyKernel installation. Okay, regarding the utilization, so this is the question. The first 4 gigs of RAM is accessible directly by the 32-bit CPU without any special handling. However, to access the remaining 4 gigs from 4 to 8, the Pi mechanism is used. This means that the operating system uses a more complex memory management system to map the physical address to the virtual address used by the applications. As a result, while the first gigs is more straightforward to use, the additional 4 gigs is managed through the Pi extension, which can introduce some overhead. In summary, with Pi enabled, a 32-bit Linux system can use up to 64 gigs, but the way it accesses the memory from 4 to the end is more complex due to need to Pi. And let's ask one more question. Does it mean that Pi kernel is so the kernel does not exactly shuffle. That's how I ask the question. Page tables. The PyKernel uses a hierarchical page table system to map virtual address to physical address. This system consists of multiple levels of page tables, each containing pointers to the next level of page tables or the actual physical memory. Page size. Okay, memory access when the application. I'm not getting any substance from this answer. Okay, so I was actually wrong. All of the applications are able to access all of the RAM. It's just that the way that memory management works in this environment has clearly some overhead, so I guess it's a bit slower. Yeah, of course, this is most obvious. I did not mean this. When the application accesses memory beyond the 4 gigs limit, the kernel uses the additional level of page tables to translate the virtual address to a physical address, introducing some overhead. So basically, all is good, it's just slower. I'm catching up with chat. I remember Adele says, I remember conventional memory, high memory managers, yeah, in DOS, but not the name of the program used. QM, it was called high mem in DOS, highmem.sys. Did anyone write that in chat? Not yet. Look up what highmem.sys is. Quarter deck, expanded memory management, memory manager. In the past, I twirled QMMM so that had okay, kilobytes. Yeah, was great. It was essential for 3D work, but a pain to work with memory management conflicts with hardware. Okay. Let's go, boys and girls, if there are any in the chat. As soon as the root file system is available, the kernel will mount all file system configured in etc setup, and then will execute the first program, a utility named init. Okay, so one of the important things which you might want to remember if you are going to be interviewed for a job where you claim that you know how to work with Linux. You know, the people who the technical persons who participate in hiring process. I'm not talking about HR department, but technical guys. They tend to ask 3 questions. Okay, and one of the things that a lot of technically competent people know to ask people, like, what is the first process, like on the Linux, like which process has the number 1. So if you type ps, you will get a lot of processes running on my computer, right? So for example, I don't know, this is Brave, and Brave is a process 108,552. But which one is the first? Can you guess? Which process is always the first? PID1, yes. Chep Heavy PID1, exactly. Which process is always PID1 on Linux? By now you had enough time to Google it. Okay, let me show it up to you. Same command, less. Can you see it? This might not be a very useful information for you as a system administrator. Maybe it will, maybe I'm lying, but I think there is a lot higher chance that when you try to get hired for a job, there is a pretty good chance that someone will ask you which process is the PID1, first process. And this is more of a trick question because people who train Linux, people who are self-trained, basically, they never come across this information because it's not that relevant, right? You might notice it at some point, but usually when you list processes, usually you're searching for the process you want to kill. That's the most common usage for showing processes. So the most common way how I use the command ps or ps is to grep, apologies, to grep a software that I want to kill, right? So let's say OBS, there is a whole bunch of processes here going on, but you know, when you want to kill something, you just grab the name and you will find the PID and then you kill it. Mark says, I just read this and I forgot. This is the reason why I hid it with the command line, right? Because I know that it says below, but Zoran says lib system. Zoran, I'm actually not following if you're telling me something or to somebody else. I guess Vladimir and Zoran are talking. Okay. The init program is responsible for running all initialization scripts and system demos. There are distinct implementations of such system initiators, apart from the traditional init like systemd and Upstart. Once the init program is loaded, the initramfs is removed from RAM. Yeah, the answer is init. It does not depend on which init daemon you have. It can be systemd or SysVinit or whichever. The name will always be init. No, I have systemd as well. See? I have systemd as well. And it's still called init. It doesn't matter. It will always be named init. I'm talking just about PID1. Zoran, your PID1 is systemd? I'm confused. But I might have learned something today. How is it that there is no PID0? I'm going to look up this after the stream, but to the best of my knowledge, this is a really strange scenario. Maybe it might be something new with systemd that I don't know. What is the command to find that again? Just ps. Look, I have problems spelling in English. Just this. So ps is the command to list processes. AX are flags to get more details. And you use pipe to pull the result through the less command. And the reason why we are doing this is because you want the whole screen to stop as soon as it reaches the end of the first screen, because the answer to your question is in the first line. So that's why we use less. You can use more as well. You can use more. More does a very similar thing to what less does. More, less. The difference is that more basically only goes down and less can go in both directions. Okay, I found the answer. The internet says that if it's common for sbin/init. Let me just pull it outside. It's common for sbin/init to be a symlink to systemd, which means that when you see sbin/init as pid1, it's actually systemd running as the init process. So it's like a symlink. But let's just verify this. Let's just verify this. So sbin/init. Let's see what this is. So list the contents of the folder with some flags. So we want details of the file. We want some meat, and we will not list. We will not list the entire sbin folder. We just want init. Okay. So what this says is that indeed this is just a symlink which leads to systemd executable. So there you have it. I guess I am used to having this symlink because I never really gave it a proper thought. I just remembered that it's called init, and I didn't have too much need to verify this over and over and over again. I just remembered it at one year that it's called init, the pid1, and then I never looked it up after that. So I guess the answer, if you want to sound professional, I guess the answer to which pid is the first one, pid1, is it would be the init daemon. That would be a better answer maybe. So you can say that it is called just init, or maybe it's called to whatever the name of the init daemon is, depending whether it is a symlink or not. But I think the good enough answer is that pid1 is init daemon. Yeah, okay, the splash is just something regarding the like a faceplate of the. I think that's a command to pass to the init daemon, so it doesn't show you the loading lines, just to show you the graphics. Okay, Vladimir. Well, FreeBSD, as far as I know, but this might be a little bit of guesswork. FreeBSD is not as convoluted as Linux, and it only has one init system because it's a cohesive operating system, right? Linux is a bunch of Lego bricks patched together, right? So yeah, so I would guess that FreeBSD only has one init system because there is no meaningful reason to have more than one. Okay, let's go through some standards. Okay, so this is the oh man, Chap Heavy, thank you very much. Thank you very much. I don't know. I actually see who received your presents. Chap happy for the win. Okay, I took a screenshot of this. This is awesome from your chap happy. So who received your presents? Sarah. Okay, we have some women or women on the stream, and I did not even know. A little darker. David Ziantra, Killing the Monkey, Gonzalez Games, Scuffed Joss, John Miller, Mike Jones, PNX World, Razvan Birishan. Razvan Birishan. I'm not sure if this is Polish. I apologize. Yes. I don't know if I can. Can I gift any? I can't. How did you even do that? Fan funding? What is this? This is to see the okay. To see what happened. Okay. So to the 10 of you who have just received the membership, what you can access immediately is the stream from the past week, right? That one will be unpublished today because the way I'm doing this is I'm teaching people live whatever I know, and some of these good guys and girls in chat are also teaching me back. So we are both teaching each other, and we want to pass the exam, right? And it is really cool to have this live conversation as much as do all of these tests. And I want to I'm missing a word in English, but I want to entice people, if that's a good word, to be present on the live stream by unpublishing it after a couple of days, right? So I prefer people to be present on the live stream and be constructive in the conversation. So whatever these fine gentlemen have been saying all the time in chat, even if it sounds a little bit off topic, we can always make it on topic because the whole system, when it's more interactive, it's better, right? But if you have the 10 of you who have received a gift, if you have missed the first stream, you will be able to access it through my channel membership. I have video on demands, right? You can watch it in reverse, and also if you decide not to continue your membership, even then, if you don't decide to continue your membership and if you don't make it to the live stream, even then you will be able to watch my stream for free. But I give it a limit of 7 days, right? So because you need to pay attention to the lessons in order, you really shouldn't skip them. So I hope this explained it. Chep Hebi says it took me a while to find out for your channel. So where the button is, right? Because I actually don't know where the button is. Chep Hebi says encourage, incentivize. Yes, so all these words are good. Good. SysVinit standards. So this is one of the first standards, if not the first one, and it actually does not come from Linux. This is a init system that came. My apologies. Hell is coming out of my mouth. So SysVinit standard actually came from somewhere else, from Unix, and Linux has adapted it for its own needs. And it has been with us for a very long time, okay? From basically the very beginning to I'm going to drop a random number now. Like, I think systemd kind of took over like 10 years ago. And I'm not saying that systemd was created 10 years ago. I'm saying that systemd has took over on the more popular distributions somewhere around 2014, plus or minus a little bit. Don't take my word for it, but you can Google it. The reason why systemd took over is because it has some benefits. The reason why some people hate it is also always an interesting topic, not for this stream because it's a longer topic, but let's say that Linux has kind of arrived as a deficiency in the free software space, while Unix was the only choice, and it was paid and proprietary. And when Linux was created, it was a lot alike Unix. What I mean a lot alike Unix is that a lot of tiny programs would fit together and add to each other value, right? So init system would do one thing, kernel would do one thing, login manager would do something else. You would have logs manager that would do something completely different. And all of these components make up the entire operating system. And each one of these components has traditionally been in charge of a single thing that it would do very well. Okay, it would not put its fingers into the where it's not supposed to, right? So the init system, like sysv, would take care of starting applications, not applications. I mean daemons and scripts, right? For when it boots up and etc. But at some point, SysVinit has lacked a meaningful development, and some people took it into their own hands to make something new. Okay, this is where this came from, and this is where this came from. So how things happen in Linux, right? If you don't like what it's on offer, make it yourself, right? And for some reason, this kind of stuck around, but actually this one was the this one tried to take over the first. So at one point, Canonical wasn't happy with SysVinit, so they made Upstart. And like it's usual with Canonical and Ubuntu, everyone hates Ubuntu, right? Being a good reason or not, let's just hate because that's the trend. Everyone hated Upstart, and somehow a systemd was born, and it was deemed to be better, and eventually Canonical gave up on Upstart, and they made systemd to be their default init system, and Ubuntu being one of the bigger distributions out there, and then Debian crossed over to systemd. There was a lot of I wouldn't say politics, but there was a lot of argument involved in the beginning because a lot of people really cared about SysVinit and really did not want to switch to systemd. They just did not want. And many years later, we now see the reasons why these people did not want systemd to take over. And this is because systemd is putting its hands or limbs where we could argue they don't belong. And I say we could argue because something systemd actually does better, but sometimes it makes sometimes it creates new problems. For example, SysVinit never touched the kernel in any way. Systemd has its hands inside the kernel. So in the future, if the Linux kernel starts crashing, there might be a chance that kernel is not the one to be blamed, but actually systemd who is being able to manipulate the kernel. Also, systemd is now in charge of the login session. When you boot up your Linux and you have a login screen, this is what systemd is now managing. Previously, you would think that SysVinit was doing this. No, it wasn't. SysVinit would only be in charge to get the login manager daemon up and running, and then daemon would take over and do its thing. But now systemd is telling the login daemon how to behave. So systemd, in one way, is good at how do I say it in a positive way? It's good at keeping an eye on a lot of things at once. And let's say that you have an orchestra, right? 100 people playing violin and the contrabass and, all this stuff and trumpets, and some of them are singing, and all of them are managed with one guy who is simply doing this all the time. Okay, so this is systemd. What might be the problem with this is that some of the applications might need to be remade in order to properly function with systemd. And once this happens, then the maintainers, the actual upstream developers of said application, then they put their concentration on systemd. And what happens then is that their software starts misbehaving on other Init systems because the developers are paying attention to this one. So the distributions which are using this Init system, are now suffering a little bit. And then some in-between solutions have had to be worked out and programmed to patch these problems. So, for example, what I told you, that systemd now manages your login daemon. If you have a distribution which uses something else like SysVinit or even FreeBSD, then when you come to SDDM, which is a login manager from KDE, this login manager relies only on systemd. And how does it even work in systemd init at all is because there is a middleman in between. I think it's called seat daemon. So seat daemon, please fix me if I told you the wrong answer, but I'm pretty sure it's called seat daemon. This one is now sitting in between the login procedure and SDDM, which is the login manager from KDE. And KDE expects these seats to be managed by systemd, but since we have no systemd on some distributions, then we need to have this seat daemon, which then talks to the SDDM from KDE, and it's telling SDDM, yo, I'm systemd. Tell me what you need from me. And then on the other side, it tells the SysVinit what's going on. So it's a middleman, and this was what I just described was basically unnecessary to be created or programmed, but unfortunately things are heading in this direction, and in some cases it is getting more difficult to stay with this init daemon. So people are doing their best to cover all bases to the best of their knowledge, which in turn makes Linux even more convoluted than it should be. Token charge is incentive to watch also. I have learned that there is no more time in the future than there is in the present. Hell is coming up in my mouth. Yeah. Took over from cron job. There are advantages to both. Yeah, exactly. There are advantages, but I use systemd, so it's not like I'm against it like against the devil, right? But I'm paying attention to where there might be a problem. You know, it is good to understand what is going on under the hood, because if we follow the systemd development to the end of the world, and if things start to go wrong, you might be inclined at some point to go back to SysVinit based distribution, and you will probably want to know how to make these things work, right? So to how to patch things together so that applications or daemons that depend on systemd are able to work with any other init daemon, because there must be some middlemen developed to make this possible again. So this is unfortunate, but you know it is a part of what we call init freedom. Okay, this is literally called init freedom. One of the distributions that is dealing with just this one topic called init freedom is Dev1, and this distribution is literally a mirror of Debian. It's almost exactly the same, except they swapped systemd back to systemvinit, and all of the software that is unable to function without systemd, the Dev1 developers are making it possible for their distribution. They are patching it to the best of their abilities and working with other developers who are making these middlemen possible. So if you want to have a choice, then I mean, Linux is all about choice, right? I'm not saying that being convoluted is necessarily a bad thing. It is a matter of choice. So if we have choice, then then we have choice, right? That's how it works. So if you tell me that I can choose between systemd and SysVinit, but SysVinit no longer works because all of the new tools are not compatible, then it's not really like I have any more choice, right? So some of the people are on it. They are on it to take care of the people who prefer this. So if you don't really care about this as a user, then simply don't. That is perfectly fine. But as a system administrator, you will probably want to be aware of the differences. And that's why I stop for so long to give you some of my experience, no matter how small this is. But I think it's a valuable addition to this PDF, which doesn't really talk, right? It's just a bunch of letters here as a guideline for us. Del says, no, it's really used by Antisk, Dragora, and Void Linux. Vladimir, I'll give my best to be quiet while topic is poetering. I don't know this word. Chep Hebi says systemd is the orchestrator. Yes, orchestrator. Del, okay, this is an exchange not for me. Dev1 runs on OpenRTS. Dev1 runs on OpenRTS. Let's verify this claim. Can we agree that we are both correct? Is that okay? Good? Are we good? Vladimir, I really appreciate you helping me with stuff that I don't know. But you're the one who is not streaming, and you have the option to Google the answer before you put it to chat. So use your powers and you know put in chat only what you manage to verify. And I'm not saying don't participate in chat. I really want you to participate in chat. It's just that other people who are participating in chat are here to learn stuff, and if you type the sentence dev1 runs on openrts, then some people might take it for granted and remember a somewhat wrong information, right? So it is true that it can run openrts, but if you want to teach people, you should give them a default option so that they know what they are dealing with, and you need to tell them why the dev1 exists, because of the init freedom, right? And they need to know that there are other options of init daemons available inside this distribution. So all of this is very, very important information as a whole, right? Not just one information. I'm sorry, Zoran, if I missed your leaving. I'm signing off. Thanks for the lesson, and hope to see you all next week at 1 hour earlier than today. Okay. Dale Anderson. Yeah, Dale Anderson. Zoran is from Central European time. Okay, he's from France. He is in France, right? So he wrote the same thing as you. 19 Central European is 18 GMT, right? So all is good. Both of you are correct. Oh, sorry, I'm just catching up with your conversions. Good. Okay, let's read what the PDF says. SysVinit, a service manager based on the SysVinit standards. No worries, Vladimir. To be honest, there are things that I'm pretty positive about, and it could turn out that I'm wrong. So I really appreciate any input from chat. But also there are some things that I'm quite positive about, and that's why I said, like, let's verify this claim, because I was pretty sure about the outcome, and I really don't mind having the active chat, no matter how you present it, right? A service manager based on the SysVinit standard controls which daemons and resources will be available by employing the concept of run levels. Okay, this is what we have touched above, like an hour or something ago. Run levels 1, 2, 3, 4, 5. So run levels are numbered from 0 to 6, and are designed by distribution maintainers to fulfill specific purpose. The only run level definitions shared between all distributions are run levels 0, 1, and 6. Okay, so 1 is the single user boot up. So when you go to run level 1, basically you will end up in a root shell. Okay, this is not a very particularly useful working environment. It's more like intended to fix your system if you have the need to run the shell at the earliest possible moment, because if you let it boot, then it doesn't boot and something breaks, right? Then you go to run level 1 to try to fix your shit. Run level 6, now don't pull my tail, but I think this is reboot. If someone will be so kind, I have not worked with SysVinit for like 20 years. Or, no, I'm lying, 10 years. Sorry, 10. 10. Please verify if SysVinit run level 6 is reboot. Systemd is a modern system and services manager with compatibility layer for the... Okay, this is really important. Remember this word, compatibility layer. For the sysv commands and run levels. This means that systemd allows older scripts that are designed for SysVinit to continue functioning. Okay, so systemd in this case is a good boy and is helping us to transition to the modern. I wanted to say modern, but I just mean new scripts and daemons designed for specifically for systemd, right? Because the syntax is quite different. Systemd has a concurrent structure, employs sockets and dbus for service activation, on-demand daemon execution, process monitor with C groups, snapshot supports, system session recovery, mount point control, and a dependency-based service control. In recent years, most major Linux distributions have gradually adopted systemd as their default system manager. And now, to be honest, I'm not going to pretend to know all these names, but later on, I'm sure that... Okay, my chat just died. Why did my chat just die? Are we still live? My all of my YouTube windows have gone. I have 2 of them here and there. And I pressed F5 and it seems to be fine. I just want to know if there was any interruption of the stream on your end. Okay, thank you. Upstart. Like systemd, Upstart is a substitute to Init. The focus of Upstart is to speed up boot process by parallelizing the loading process for system services. Upstart was used by Ubuntu-based distribution in past releases, but today gave way to systemd. Okay. I want you to go back. Okay, guys. We can drop the inits now, as Vladimir has listed all of them. We can drop that now because I want to tell you something about systemd. So a good boy systemd with a compatibility layer for the sysv system, right? Okay, so why is this important and why am I making such a drama? Okay, let's talk to the AI some more. This is not the answer that I'm looking for. AI can be useless sometimes. Okay, let's ask if we can fetch Phoronix. Phoronix, I'm pretty sure I read it there. Give me new stuff. Anytime past year. Okay, what I'm searching is the date when systemd will no longer have compatibility mode for SysVinit scripts, because I am fairly confident that I have read that this day has actually been announced, like an actual date. Which is the date of this article? May. This is I cannot find this now. If you have the time, try to find it. If I'm not mistaken, but I'm quite confident that systemd has officially announced when the support for SysVinit compatibility ends. So this is something that that I wanted to check. Okay, let's go to initialization inspection. Errors may occur during the boot process, but I think we are close to the end actually. Errors may occur during the boot process, but they may not be so critical to completely halt the operating system. Notwithstanding, these errors may comprise the expected behavior of the system. Vladimir, you try it instead of me because I'm halting the stream too much by searching for stuff that are not that relevant, right? All errors result in messages that can be used for future investigations, as they contain valuable information about when and how the error occurred. Even when no error messages are generated, the information collected during the boot process can be useful for tuning and configuration purposes. The memory space where the kernel stores its messages, including the boot messages, is called the kernel ring buffer. The messages are kept in the kernel ring buffer even when they are not displayed during the initialization process, like when an animation is displayed instead. For example, you're booting Ubuntu and you want to see the Ubuntu logo, right, and the black screen. However, the kernel ring buffer loses all messages when the system is turned off or by executing the command dmsg clear. Without options, command dmsg displays the current messages in the kernel ring buffer. If you remember from the previous stream, we have been using dmsg to see how the kernel is recognizing freshly plugged in USB drives, right? So for all of you who have not been on the first stream, but you might watch it on a video of demand. Let me just repeat that. Okay, so you see that the last thing in kernel ring buffer is Steam Web Helper. And now let's plug in a USB stick. And what happens when you plug in a USB stick is that the kernel recognizes a hot plug device and it assigns a device name to it. Okay, so let's do the kernel bring buffer again. So now you can see we have a whole lot of new messages, right? High speed USB device. The brand is Buffalo, which is correct. Flash drive, it's 4 gigs big, and it was assigned a device name SDC, so /dev/SDC. Okay, so I'm going to just pull it out quickly, and it is now unplugged. And let's call the kernel ring buffer again, and that is it. It is now recognized as no longer present in the system. So we have been having fun with this command in the previous stream, right? Chep Heavy, from what you have read so far, the boot process goes as follows: BIOS/UEFI, grub, loader, kernel, init. Well, grub and loader is basically the same thing, so you can put them in one field. I mean, grub is the kernel loader, right? So you can put them as one thing. So the example in the PDF is showing us something that we could see on the kernel ring buffer with the message command. The output of the message can be hundreds of lines long, which is correct. So the previous listing contains only the excerpt showing the kernel calling the system the service manager. The values in the beginning of the lines are the amount of seconds relative to when the kernel load begins. You're welcome. In systems based on systemd, command journal_ctl or ctl will show the initialization messages with options B, boot, K, or the message. Command journal_ctl list boots show a list of boot numbers relative to the current boot, their identification hash, and the stamps of the first and last corresponding messages. I apologize for my nose. You can probably hear it by now. It's in trouble. Vladimir says eventually. Okay, I'm gonna dig through that after the stream because I'm a bit puzzled. What did I remember? Let's go with this command and see what it looks like on my PC, right? So on Linux, when you are working with the terminal, when you just mark something somewhere, for example, in this PDF, I did not press Ctrl+C. I just marked it with a mouse, and as soon as it's marked, you can go to terminal and press the middle mouse button to paste it from this buffer. And this one is slightly different from the one that you use with Ctrl+C and Ctrl+V, right? Oh crap, I need to fix my nose. It's kind of a trick that might be handy at some point with copy pasting, right? Let's do this sudo. Okay, list boots. So what do we have here? Can we go up and down? Yeah, we can. So good enough. So 113 boots ago. So this is the first entry that we have here. And this is when was this? Yesterday? Yeah, yesterday. I think I yesterday did a bigger Arch update. So these are our boots. So this is a fairly useful command, right? You could use uptime to see how long the system has been running, but in some cases you might want to see more about your previous boots. It might come in handy for some of the aspects of how do I put it, system administration, right? You can play around with these messages on your own if you like, with these other commands. Shift insert. Vladimir says, my keyboard has no insert button, or at least I haven't programmed one. So there is that. Previous installation logs are also kept in systems based on systemd, so messages from prior operating system sessions can still be inspected. Mark Carpenter says that copy paste works. That has confused me at times when it has pasted something that I didn't copy. Yeah, it's actually practical. I use this method very often. I also use the Control C and V, but usually not in terminal. But in terminals, the reason why you can't use Control C is because the terminal depends on Control C for something else. So you have to use Control Shift C or Control Shift V to paste something. If you have captured that with Control C from a different application. So play around and see how it feels, so you can get a better grip on it, how it works, right? You can combine them both. Previous installation logs are also kept in systems based on systemd, so messages from prior operating system sessions can still be inspected. If options B0 or boot 0 are provided, then messages from the current boot will be shown. Options B1 or boot -1 will show messages from the previous initialization, from two of them backwards, etc. The following excerpt shows the kernel calling the systemd service manager for the last initialization process. So let's go and use this one here. Sudo. Okay, and we are now observing the latest ring buffer. But there is another way how we can do this, which is what we did on the previous stream. If you, Vladimir, if you can remind me, is it less the message or something like that? Anyways, this is our latest boot, right? We have booted yesterday at 6 p.m. my time. I'm not going to pretend that I know all of these lines, but when you need them, you will know them. EFI by American Megatrends. Okay, that's our UEFI, SM BIOS, MicroStar. This is MSI motherboard. Chep Heavy, not the message. The message lists everything, but I want the message which will stop immediately and give me the option to scroll slowly. So was it the message or ls the message or something like that? So basically, this is our whole kernel buffer, right? But when you type the message, you get it in color, so it's a little bit nicer. But all the info is still here, right? Kernel boot parameter. Chep Happy says I'll do the message pipe less as a workaround. No, you will not. Go try it. Go try it. Literally, go try it now. Let me check, okay? I'm looking forward for your findings. Okay, so the ring buffer is pretty big. Let's see if I can dmsg. Okay. Oh, it must be sudo. Okay, so that's the in color version, and let's see if I can do the dmsg minus color console ctime file. Wait for new messages. Okay, so it might be minus w. Dmsg minus w. Yeah, that's. Oops. No. That's sorry. Sorry, no, that's the. Actually, Chef Heavy, you are correct about less. I mistook it for something else. What the last time I had trouble with is I wanted to see my tail. Okay, do you know how tail works? I wanted to follow the tail of the message on the last stream, and it did not want to follow, right? Okay, see, I can tail it, but it doesn't follow, it just exits. Yeah, Vladimir, correct. This is the thing that bothered me the last time. So how you tail the message is you just pass the minus w parameter, okay? And then you can plug in something to trigger the ring buffer to show you more stuff. Okay, wrong side. There we go, plugged in. Okay, this is our stick plug in, and now I'm going to plug it out. And now it's plugged out, and you can see live how the ring buffer is responding to hardware changes. Pendragonian says tail minus f did not work the previous session. Yeah, correct. So I apologize that I misled you about less. It's just that I mix it up in my head. But all is good. Mistakes are good and teamwork good. I love this. I love the teamwork. And I'm pretty sure Vladimir is the one who has found the minus w command the last time. Okay, initialization and other messages issued by the operating system are stored in files inside directory var log. I'm pretty sure that you all know about this. This has not changed for a very long time. Actually, let's sudo minus I. Do you know what sudo minus I is? It will become root. Literally, I'm going to transform into root, just like I have logged in as root from scratch. So it will execute all my startup scripts that I have in bash or whatever I'm using, right? There we go. Now I'm root. And we can go to just for a short time. So what do we have here? Like xorg log. Let's see that one. Less xorg 0.log. So I'm not going to go through this. I just wanted to show you how xorg is dropping some log files, and this is where you can, if you have some problems with picture, this is where you could maybe see something that hasn't loaded properly. Maybe a driver is giving you trouble, and kernel models and the resolution, initialization, recognizing monitors, and stuff that defines the very fact that you have the picture on your screen, right? I'm not sure if it works for Wayland though, or just for X11. So you might be wary of that. So these are very keep some logs, right? We can read interesting stuff here when troubleshooting. If a critical error happens and the operating system is unable to continue the initialization process after loading the kernel and initramfs, an alternative boot medium could be used to start the system and to access the corresponding file system. Then the files under var log can be searched for possible reasons causing the interruption of the boot process. So the way I do this usually, if you have watched me trying to install Arch Linux live on stream 2 weeks ago, maybe, I have tried, I'm not that good with Arch Linux, right? I have switched to Arch Linux for the first time in my life 6 months ago. So I have installed it 3 times so far, 2 times, once on my PC, once on my laptop, and once live on stream. And what happened is that I tried to prove to people that it is easy to install Arch simply by reading Arch Wiki on how to install Arch Linux, like literally copy pasting commands with understanding, okay? And what went wrong is that I was rushing it, okay? I was talking to chat. I wanted to make it as fast as possible to make it, interesting, not as a racing, but just to prove that it is easy, right? And what happened is that when I did all of the steps and installed grub, I rebooted, and UEFI has loaded my grub, and grub just halted with the command line and asked me, "What is it that you want from me? I'm here. I'm grub. I don't know what you want from me." And then I was like, oh, shit, like I forgot something. And then we all rebooted back to the Arch installation media, the very same one that we used for the installation. And we fast forwarded a couple of steps with setting up the keyboard and time zone and, the first few steps. And then we mounted the file system, which was already installed, and grub is installed, right? And then we paid attention to what did we forget. And what do you know? The only command that we forgot was grub install. Actually, not grub install, I did that. The one after that, grub make configuration. I think it is called grub dash mk config or something like that. The command that generates the config file for grub. So in theory, I could have booted the system if I would type the exact correct command to pass to the kernel. However, I just went back to the installer and I only added this one remaining command, and then we rebooted and the system booted up properly. So this is a good way to learn how to use the installer as a backup media to access the system that does not want to boot at all. And if you're interested in that, the stream was actually quite funny. It's called, I think it's called Learn Something. It has a green Pepe meme with Arch logo on his chest. Find in my videos green Pepe meme. That's the stream. Okay, so Vladimir says -I is the same as login. Okay. Wayland logs journal -b grep Wayland. I am pretty sure that's one of the ways. And there may be more. Where was I? Okay. So booting up into the sort of a rescue environment, right? Alternative boot medium. Basically, it wasn't alternative for me. It was the same as I used to install the system. Then the files under var log can be searched. Yeah, you mount the partition and you read log files. So this is good. Options -d or directory of command journal settler can be used to read log messages in directory other than var log journal. Okay, this is something that you can experiment with, and I would encourage you to do exactly that. Use your system and see how these commands behave. Which is the default location for system.log messages. And as system.log messages are not stored in raw text, command journal_ctl is required to, I wouldn't say read them, but it's a good word. What is the word? Not encryption, but scrambling, to unscramble the logs, right? And we're getting to the end. Good. This is where you all shine. This is all 10 of you where you will shine. UEFI, on a machine equipped with a BIOS firmware, where is the bootstrap binary located? This is where you guys answer the question. On a machine equipped with the old BIOS firmware, where is the bootstrap binary? Iceblade is wrong. Iceblade is rewinding the documentation. Pendragonian is also wrong. Actually, Pendragonian, you might not be fully wrong. Jebhebi is correct. Jebhebi wins this one. Okay, question number 2. Also note that below this we will get the actual answers, okay? So if I was wrong, then we will see how I was wrong, right? So don't worry about getting the correct answers. UEFI firmware supports extended features provided. Iceblade, nice. UEFI firmware supports extended features provided by external programs called EFI applications. These applications, however, have their own special location. Where on the system would the EFI application be located? I think the answer to this can be said in a couple of ways, while all of them are being correct. So Vladimir is being a fool for fun. Okay, so where on the system would EFI application be located? EFI directory is pretty correct. Also, EFI specific partition is even more correct. And Iceblade is wrong again. Yeah, okay. Mark and Dell together are winning this one. And I said together because Dell has answered second, but Dell's answer is better. Okay, so in my opinion, Mark and Dell get 1 point for this one. Bootloaders allow the passing of a custom kernel parameters before loading it. Suppose the system is unable to boot due to a misinformed root file system location. How would you correct root file system located at dev SDA3 be given as a parameter to the kernel? Okay, so this is difficult, but try to be, if you cannot give the exact command, try to be vague about it. So which kernel parameter will tell the kernel to boot the root file system from here. Boot flag is on the right track, yes. We need more substance. Which boot flag? Chep says should be to mount file system equals in. Okay, the Chep what you wrote here is a little bit messy. It's not the init command, Iceblade. Mark is the most correct so far, but yeah, it's the root parameter. Okay. I guess del is the fastest one to scroll back. It's the root parameter that you're handing over to the kernel, right? So in group, you will say this is the path to the kernel, and this is the root file system partition that we need to be loaded as root, okay? Iceblade, you are free to skim through the entire lesson in the PDF. You don't have to rewatch everything because you have participated. So what I would advise is sleep on this. Don't do anything today. Sleep on this, and tomorrow just read the second lesson from the PDF just once. And while reading it, a lot of things will click. It's fairly it happens to most people like that. Yeah, Vladimir, you are correct. Yeah. Oh, Del, I thought that you are saying root flag. That's why I said okay. I thought that you're saying the same as Vladimir is saying, but yeah, Vladimir has written it the correct way. I just thought that you're being vague. But yeah, root equals. You have to tell which partition. The boot process of a Linux machine ends up with the following message. Alert, dev SDA3 does not exist, dropping to a shell. What is the likely cause of this problem? Okay, this question is a bit cryptic. Boot process dropped to shell and given an error that it cannot find a partition. Why would the boot process crap on itself if the partition does not exist? Iceblade is being funny, but it could be what Iceblade has responded technically could happen if you unplug it in the right moment, but let's say that you're not doing that. Ten more seconds and then I will give my answer, my best answer. Chep Happy wins this one. Okay. I am fairly confident that Chep Happy is correct. That it cannot find the root partition. Okay, so let's see. Exploration exercises. The bootloader will present a list of operating systems to choose from when more than one operating system is installed. These are not just a second. Guided. Okay, the answers are still even more below. Let's read some more questions first. The bootloader will present a list of operating systems to choose from when more than one operating system is installed on the machine. Bootloader, grub, let's say. However, a newly installed operating system can overwrite the master boot record of the hard disk, erasing the first stage of the bootloader and making the other operating system inaccessible. Why would this happen? Why would this not happen on a machine equipped with UEFI firmware? This is a really good question for Vladimir. Vladimir is the only one who did not want to learn this. So you have Linux installed and it works. And then you install Windows, and now Windows works, and you can no longer boot to Linux because the Windows bootloader has overwritten the master boot record. And the question is, why would this not happen on a machine equipped with UEFI firmware? Iceblade is correct. Everything you type after Iceblade is relevant because that's the correct answer. Let's go. What is a common consequence of installing a custom kernel without providing an appropriate initramfs image? Mark, you're correct. Usually you would install Windows first and then Linux. So Linux would take over the booting Windows via grub, right? There would be an entry in grub that can boot into Windows. But even if you install Windows last, you can still boot a Linux rescue media and then simply install grub once again. Just overwrite the what Windows did. What is a common consequence of installing a custom kernel without providing an appropriate initramfs image? I forgot the details from above in the lesson, but the procedure was that with the kernel, you need to have a matching initramfs image, which will load first, and then when the kernel loads, then the initramfs image will unload from memory, and the whole thing will be transferred to the next phase. I'm not sure if it's if we are still on kernel or we have switched to init daemon. But I think it is the next phase after initramfs image. This one must be before the rest. There are steps, right? Initramfs happens in the beginning, and then it unloads, and then other stuff load. Shabhabi, I'll blind shot my answer to this one. You won't be able to allocate anything into memory. Init won't see the kernel. All of these answers are pretty good. Let's see what the actual answer below is, because we have went through the guided exercises first, and then we switched to exploration exercises. So the actual answers are soon, very soon. the initialization log is hundreds of lines long, so the output of the message command is often piped to a pager command, like command less, to facilitate the reading. Okay, what the message option will automatically paginate its output, eliminating the need to use a pager command explicitly. Okay, this was either not in the lesson or we haven't tried all of the commands. Was it the message minus K to replace less, to replace piped less? Let's see, was it minus K? No, it is not. Let's see which one acts as less. Minus F. I don't know this English word, but it sounds as close as possible to what less would do. And no, it's not. Or maybe it is. I don't know. Which the message command is so we are trying to Iceblade. We're trying to find out which the message command. Okay, so the message, which the message command will do the same as this command. Okay, so what this command does is it pipes. This is a pipe, right? This command pipes the message output through the program called less. So what program called less does is it takes the amount of text as an output that is larger than the screen, and it stops when it comes to the end of your screen, no matter how big it is. So you can scroll up and down through that file, right? Let's call it a file. So we want the exact same. Let me show you. So this is less, right? You can go down, you can go back up. And what we want is which the message command does exactly the same as piping through less. Vladimir says minus K is kernel messages. Dale Anderson says minus big P. Nope. Maybe capital H. Okay, who said H? Dale Anderson. Okay, this is the answer. Yeah, ChapHappy is correct. Minus W is similar to tail minus follow, to tail follow. So Dale Anderson got this one correctly. Let me just see what is it called. The message minus H. So it's human. I literally skipped over this line when I was reading because this means nothing to me. This is, I mean, the message is already in human readable format, so it's just running away too fast. So why would the parameter that mimics less be called human? This is bizarre, if you ask me. Okay, so it's minus capital H. Yeah, good. It's just a bizarre. Yeah. A hard drive containing the entire file system of an offline machine was removed and attached to a working machine as a secondary drive. Okay, so this is a similar scenario to what I was giving you example today. Assuming its mount point is initd, how would journal.ctl be used to inspect the contents of the journal files located at initd varlog journal? Dale Anderson says Q. That is correct. So we have transferred a hard drive from a dead computer to a different computer, which works. So now our transferred hard drive is second. How would journal.ctl be used to inspect the contents of the journal files located at this location? And this location is our second computer, which works, and we have mounted the drive that we took from the first computer. We have mounted the drive to this location, right? It doesn't matter which device is it. It is already mounted, and when we go to varlog journal, how do we use journal.ctl to read logs from this drive instead from the actual boot drive of the second computer? Iceblade forgot what journal.ctl did. It reads logs of the systemd. And it is also able to read logs of systemd, not just from the default varlog journal, but also it can read logs from a different location. I see that you are all stuck on the previous question. So the way you would use journal.ctl to read logs from a different location than the default one is simply by using a flag on journal.ctl, right? So let me just go back to okay, we have been inspecting. Okay, this is how we inspected our journal.ctl logs with our location, right? But there is a flag that we can use to watch from a different location, right? So Dale Anderson says -u. Let's see. Show logs from the specified unit. This actually sounds correct. Yeah, I think it is. Summary. What about -i? -i is show journal file. Oh no, crap. This is the correct answer. -d. This is the correct answer. It's not U or I. It's capital D. It's capital D because The question is, how would journal settler be used to inspect the contents of the files located at this folder? So it's plural. And then you give it minus capital D. And let's see who is correct. This lesson covers proper knowledge of how the boot process of a Linux system works, help prevent errors that can make the system inaccessible. The lesson goes through the following topic areas: how BIOS and UEFI boot methods differ. Good stuff. Typical system initialization flags, recovering boot messages, the commands and procedures addressed, common kernel parameters, command to read boot messages, the message and journal settler. Okay, where are the answers? Okay, let's... on a machine equipped with a BIOS firmware, where is the bootstrap binary located? Bootstrap is in the master boot record of the first storage device as defined in the BIOS configuration utility. So I confirmed the person who said in the first 440 bytes, which turns out to be false, and the person who said MBR previously, which I claimed to be wrong, it was actually right. I forget who typed what, but you know who you are. Let's see the second one. UEFI firmware supports extended features provided by external programs called EFI applications. These applications, however, have their own special location. Where on the system would the EFI application be located? EFI applications are stored in the EFI system partition, located at any available storage block with a compatible file system, usually a FAT32 file system. So this is a full answer, but basically we have already answered that it must be inside the EFI system partition, right? I think we were successful at answering this one, no matter that the full answer says it must be fast. It must be compatible, right? File system. It's not just FAT32, also FAT16 and 12. Bootloader allow the passing of custom kernel parameters. How would the correct root file system be given a parameter to the kernel? So Vladimir said root equals dev sda3. I'm pretty sure it was Vladimir who in the end wrote this. So this is the correct one. The boot process of a Linux machine ends up with the following message. SDA3 does not exist, dropping to a shell. What is likely causing the problem? The kernel was unable to find the device dev SDA3 informed as the root file system. So I think we were all on the same page on this one. I don't remember anyone giving the wrong answer to this. Some of you didn't type anything. Some of you typed the correct answer. So I think we're good on this one. Oh, now the answers to exploration exercises. The bootloader will present a list of operating systems to choose from when more than one operating system is installed. However, a newly installed operating system can overwrite the master boot record, erasing the first stage of bootloader and making the other operating system inaccessible. Why would this not happen on a machine equipped with UEFI firmware? And if I recall, yeah, happy Monday to everyone in Central Europe. Why would this not happen on a machine equipped with a UEFI firmware? I think Iceblade answered the first. He said UEFI machines do not use the hard disk's MBR to store the first stage of the bootloader. Am I correct? It was Iceblade who answered this one. I need to give credit where credit is due. What is the common consequence of installing a custom kernel without providing appropriate initramfs image? The root file system may be inaccessible if its type was compiled as an external kernel module. Okay, so I think nobody answered this one. Am I correct? I don't think anyone answered this one correctly. We all said more or less that initramfs must be the first one. And basically it is, but the thing is initram file system will load when we give the system a custom kernel, right? It will just load the wrong kernel. So what this answer has taught us now is that well, what it says here, right? This is a little bit convoluted as an answer, but if you have a working kernel with its matching initramfs, everything will boot. If you leave current initramfs and just change the kernel to something custom, then the root file system may be inaccessible if its type, so the root file system type, was compiled as an external kernel module. And I would say that this is a problem because the external kernel module is loading later after initramfs was correctly done. So I think this is actually a fairly difficult question. Okay, Vladimir. Okay. Third one, the initialization log is hundreds of lines log, so the output of the message is often piped with less to facilitate the reading. What the message option will automatically paginate its output, eliminating the need to use less. What did we say? I forgot. Oh, it was it human? Was it the human thing? I think it was. Yeah. The message minus h. So that one is on Chep Heavy, I think. Apologies if I'm giving credit to the wrong person. I think Chep Heavy answered -h. Okay, the last fun one. A hard drive containing the entire file system of an broken machine, offline machine, whatever, was removed and attached to a working machine as a secondary drive. And we will use journal.ctl to read the folder of a guest hard drive, right? So in the end, someone said, Vladimir said -i, Dale Anderson said -u, I said -D. So there we go. I don't want to take credit for this one as I was just reading from my from the help system of the message command, right? So we have, as a community, we have successfully concluded this answer. But this one is difficult, I must say. I think we should all, including me, research a little bit more into initramfs before next Sunday. At least read a little bit more on the internet about how this behaves, as it might be important in the future. Next level, next Sunday, right? To be honest, I am quite a lot drained. If you are in the mood to chat a little bit. I don't mind. But it should be fairly not too long, right? As it is past midnight and I work in the morning and I'm sick, and I will see how will I combine this with my boss. Dale Anderson says tomorrow we'll review. This is harder than last week. I agree. This was harder. Cap Happy says pretty good. Mark says I don't know why you would load a kernel like that. Why would I load a custom kernel? So a custom would probably mean that I have compiled it myself. Why would I load a custom kernel and not provide an initramfs? Maybe because I forgot. You know, you want to prepare your own kernel. Let me just give you a short story. So nowadays we are being very spoiled with Linux because Linux, most distributions just work. It is how to put it. Okay, let me rewind, and I'm gonna do this as quickly as possible, not to drag the conversation back in the back in my day. When I think I already talked about this in the previous lesson, but before Linux introduced modules, it was very, very normal and standard that you would compile your own kernel because that would be the only way to get any drivers working. So everyone would be compiling their kernels. If you want Linux to work, you just have to. That's how you install it. That's how you configure it. You compile the kernel. I mean, it's not that difficult, to be honest. You download kernel source. I haven't done it for ages, but because I didn't have to. But even back in the day, it was fairly easy, right? You download kernel source. You need to have all the compilation software already prepared and installed, like Gutsits, Make, some others. You need to prepare the compilation environment. And when you download kernel, you untar and unzip the archive. You enter the kernel folder. I truly forgot the commands, but there were like 3 commands that I would execute every single time. And one of them was make config. Was it? I think it was make config. And what that would call, this was really a long time ago. Make config would call like a text-based interface. You would have options, and you could click with an enter to go into a menu, and then a submenu would open. It was still in a text console, so not in a graphical interface, but it was visual, right? You would just go up and down and click with space which kernel driver you want to load. And the way I would do it, I would know which hardware I have in my computer, which graphics card, which modem, which CPU, which sound card, etc. Maybe chipset. And then I would simply go through all of the menus and submenus of submenus. And when I would get to the end, I would backtrack to the next one that allows me to go into a submenu. And basically, as a tree, I would go through all of the options in the entire kernel. This would take a while, but back in the day, there was not so many drivers, right? So it wouldn't take that long. You could fool around with that for half an hour, maybe an hour, until you get it all right, and click the check marks on every driver that you need. And once you're done, you click save. It exits back to the command line. Then you type the compile command, which was, I think, just make, and then it would compile the kernel. That would also take about half an hour, to the best of my recollection. and then you just move the kernel with the install command to where it belongs. And you would need to execute the bootloader command to take the new kernel. Back in the day, we used only Lila, not grub. And once you get it all right and reboot, you boot up into a fully working system. If you messed up something with the drivers, you would simply do it all over again. Dell says, thank you for the session. Get some rest. Good night, all. Good night to you, Dell. Vladimir says, thanks, guys. Thanks, Zar. Thank you very much. Iceblade, yeah, I don't think the material explained why on some parts. Iceblade, I will not, I will never tell people what they must do. It's all up to you. What I would probably do is read this document, just this lesson, one more time tomorrow, just to how that just to put some electricity into your brain memory with reading it with your own eyes just once more. It will take you maybe 10 minutes to read all of it, maybe 15 if you read slow. I think it's a good thing to do. What I will do after this session, not today though, I'm just going to bed. I will read through the what was it? The initramfs setting. Okay, this puzzles me a little bit, and I want to learn more about this. So this is my homework. This is my homework, and you should give yourself homework on anything or everything that you believe that did not sit properly. And if you need any help, you can drop into my Matrix chat and ask some assistance there. I might not be able to reply immediately when I'm at work and such things, but Matrix is like Discord, so the messages will stay until people who are willing to answer read them. Chip Cabby says, appreciate your time streaming this. I hope you have some good rest and feel much better. Thanks for the lesson. Thank you very much, Chip Cabby, for participating in the chat. I appreciate you very much, as the whole thing would not be as fun if everyone would be just lurking, right? We have some lurkers here, and that's perfectly fine. But I like to have a mixed, I like to have some of the people who prefer to be active, let's call this a class, right? Compared to the ones who are more shy. This is both is fine, but it would be bad if everyone would be shy to talk in the chat. My voice is going completely to hell. If you want to hear something fun, when this video on demand is released, try to listen. My first sentence and my last sentence is in the stream, and see how I sound in 4 hours difference. And this is because of what's gotten into me yesterday. I don't know what is it. Chep Happy says make menu config. Yep, I think you're correct on that one. I think you're correct. Make menu config, yeah. And then make config would be probably the same thing, but just a questionnaire, right? But I was using the menu one. Iceblade promised to read it again. Good. Vladimir, on FreeBSD stable, rebuilding kernel weekly is normal thing. Okay. Chep Cabby, I'll give it a dive to initramfs and the bias UEFI again. Okay. Mark Harpetent, good evening. Thank you so much. Okay. Can I close the gate now? Thanks to all of the gifts from, like, it was, I think, 3 of you. Thank you all 3. Thank you for all the emojis, hearts, and everything else, and for participating in the chat. This is very important. But yeah, if you want to have a good laugh, hear me out how I talk, how I sound in the beginning and in the end of the stream. That should be entertaining enough. Good night, guys.